Welcome to Newegg Studios, and thank you for joining us for the launch of Intel's next generation enthusiast chipset and the 9th generation of Core Series CPUs. But as you might have noticed on this table, not just CPUs, we've got a whole variety of backbone products, the technologies that are going to help you get the most out of that processor investment that you're going to be making. And I can't think of anyone better to talk about this launch, to share, again, what consumers are going to be expecting for this new product lineup than JJ from ASUS.
Well, thank you for having me. It's a bit interesting. This is the first time it's been J&J, right?
I know, right?
Yeah.
JJ, JC.
So that's pretty cool. So first and foremost, thank
band.
you guys for for joining us here on the stream. This is a pretty exciting day. I know a lot of you out there in the community have really been waiting for this day. There's been a lot of discussion on what Intel was going to be doing for the 9th generation series of the Core Series processors, what was going to be new and interesting when it came to, of course, the latest generation of motherboards. And we're going to be diving into all of that. We're going to give you guys the ins and outs in terms of what the CPU stack looks like. We're going to be talking about, the technology improvements, the capabilities. We're definitely going to be diving heavy into the wide range of motherboards. As you can see, we've got actually boards from our entire range of series for the Z390 series lineup. And we're also going to be touching on some really cool stuff for those of you that jump into that truly high-end space with the HDET. We'll be talking a bit about that X299 refresh. There's new CPUs that have come out on that side, as well as maybe even talking about kind of a new high-end Xeon-based platform and a special board that ASUS has been working with Intel on with the ROG Dominus. So a lot of really, really cool stuff here. So hopefully you guys, as always, are going to watch the entirety of this stream and hopefully be able to get a lot of good information when it comes to the ins and outs of the CPU, the platform, who's it right for, which board to consider, and really everything you're looking for when it comes to Intel's latest and greatest in this enthusiast segmentation.
Definitely, and as we're doing this broadcast, we are doing this live. So for those of you out there, you have the opportunity to tap one of the greatest minds at ASUS in system building, in PC enthusiast builds. We're going to have people monitoring the stream, moderating the comments. If you've got some great questions, we'll try and answer them as we get to the end of the show too. So definitely looking forward to some great participation, some great conversation on what is going to be, I think, a nice step up, a nice improvement, a nice evolutionary jump for the PC builder space.
For sure. So I think the first thing is just kind of overall for us to kind of get a perspective of where things sit in the overall landscape, right? So anytime we've got a new essentially processor and then we have a new chipset, we kind of like to take perspective of where that sits in the entirety of the ecosystem, how it stacks up to the current overall CPU product stack. Is it essentially displacing anything? Is it replacing anything? And how that all works out. So I think the first thing is right now with Intel 9th gen series of processors, we're going to have 3 brand new SKUs. So we've got the 9900K, then we got the 9700K, and then we have the 9600K. There are going to be some changes in terms of how these actually parts work in terms of their cores, and they're actually turbo frequencies. This is the first time that in the mainstream segmentation, we're now bumping all the way up to a peak of 16 threads, so 8 core, 16 thread, and we're introducing 5 gigahertz true turbo base ratios on that 9900K. So we're going to be talking about that. We then also have, of course, the chipset side. So with chipset side, this is interesting because Z370 isn't going away. It is still essentially going to be staying here and is still available for you. So you'll be seeing essentially availability for Z390 series of motherboards as well as Z370 series of motherboards. And in terms of the overall interoperability and compatibility, the latest 9th generation series of processors are fully compatible actually with the previous Z370 series. All you'll need to do is essentially go over to the support website, take for instance at asussupport.asus.com or use the integrated Easy Flash option, download the latest UEFI, and that will flash the board and allow it to be essentially interoperable and compatible with these new CPUs. Now, there will be some specific benefits in terms of how we've designed the motherboards, I think to best complement the latest generation of 9th gen processors if you adopt a Z390 series motherboard along with the 9th gen series of CPU. But if you're just kind of wondering how this kind of plays out, those 9th gen series CPUs can work with the previous generation as long as you've got that update. But like I said, there'll be some special kind of optimizations there.
Now, obviously, people who would be interested in a stream like ours are probably a little savvier when it comes to the parts and pieces that are going on in their PC. But from ASUS's perspective, have you found that there's been a pretty easy roadmap with the tools Intel has provided you for making that education from 370 to 390?
Yeah, definitely. I mean, I think that on paper, I don't think there's a huge amount for the user to kind of worry about in terms of complexity of like what's really different between these two. In a little bit, we'll actually jump into a topology map to kind of be able to take a look at what the actual chipset looks like. For most intents and purposes, it's a bit more of an evolution compared to kind of being an entirely new type of platform.
Right.
But that makes sense because X299 isn't going away.
No.
While we have essentially, Intel redefining their performance segmentation, what they're offering with this now 9900K, this first Core i9 in this mainstream enthusiast segmentation, right? With that 8 core and that 16 threads, you then still have that super high-end platform with the HDET on X299 where you get, of course, quad channel, you get more PCI Express lanes, you even get more cores, more threads, right? So that is a whole nother kind of platform arc. Like we said, there are actually an entirely new range of CPUs for that platform as well to kind of redefine, I think, entry to mid to high-end space.
Everything is getting that bump up.
Yeah. So everything is kind of being shifted to allow you to have that. And the previous refresh that happened not too long ago when we were talking about in one of our previous streams where we highlighted the B series and the H series chipsets also pivot in underneath that, right? So you still now have your B and H for essentially non-overclocking capabilities, non-overclocking focused users. Then you move into your Z series, which really the key thing is that it's generally going to be expanding on the overclocking capability by introducing that as an option,
right.
not only just for the CPU, but also for the DRAM. And then you move into the HDET, right? So that gives you your good, better, best kind of scenario, right? And each one has its accorded kind of processor specification. The big thing I think we saw with B and H, because they actually came after Z370, which is the introduction of Wi-Fi as part of the overall chipset implementation,
right?
And then USB 3.1 Gen 2.
Yes.
So actually, many Z370 boards actually had USB 3.1 and even Gen 2, but the Gen 2 implementation was done through a third-party controller.
Yes.
The difference now here is that essentially on Z390 you have that natively part of the chipset. Without getting kind of too technical, one interesting thing that you guys might not realize is that there has to actually be chipset support to support different types of physical connectors. So when you see some boards that might have like USB 3.1 Gen 2 and it's a Type A, and they might be wondering like, oh, why doesn't everything have Type C if it's Gen 2 support? Right. It actually requires a specific additional hardware component to be put in to allow us to use a Type C connector. And that's just because of the difference in terms of how Type C works in terms of certain power distribution and other requirements. So
it really does feel like Z390, while we are talking about higher performance parts in the Z390 board, that this is also Intel's play at giving us a little TikTok update, the surrounding technologies, all of the backbone technologies, also reaching that maturation point where we're talking about we don't need a third-party controller for USB 3.1 Gen 2.
Well, we may still have it. I mean, when you get into the higher end space, I think users are always looking for the most features and functionalities in motherboards.
Oh, absolutely.
In that respect, we generally try to add in a huge amount of things into the boards to really be able to try to provide as much value as possible. But I think you're definitely correct that Z390, especially if you're somebody that didn't upgrade in the Z370 generation, there's a huge amount of things that have kind of shifted over to be able to really be present here in a reliable and consistent fashion. So, one of the things that we'll touch on a little bit more here in a little bit once we take a look at the block, but
we've got a lot of ground to cover, so definitely.
Is we definitely don't want to undersell, I think, that value proposition of that Wi-Fi implementation. The reason being is that for many of you might not realize that Intel actually develops their actually own Wi-Fi modules. And so this is very prevalent in a lot of course, mobile products, right? So in 2-in-1s, Ultrabooks, gaming laptops. And they're using that same actually Wi-Fi chipset that was developed on that platform now is actually available on these latest generation of motherboards. And we saw this started to be introduced actually in the B and H series of motherboards because they baked it into the chipset there. The reason why this is really cool is this is the first time that you have what's called a 160 megahertz compatible Wi-Fi module. And the reason why that's really cool is that traditionally previous Wi-Fi chips worked at either 40 megahertz or 80 megahertz. And essentially when you increase that frequency, you can have significantly more bandwidth. And what does this mean? Well, if you pair this up with, take for instance, like our new recently launched AX88U router, which supports 160 megahertz Wi-Fi chips, you actually can reach in the real world, not synthetic in a lab or some theoretical number. Of course, we're not talking about over the largest distances, but it's still realistic that you can actually see speeds in excess of 800, 900, or even 1,000 megabits. So that's pretty crazy when you think about the relative performance can actually meet or exceed that
Yeah.
of an actual gigabit Ethernet cable. So for users that are really looking for the highest level of performance, you're not only going to have outstanding Ethernet implementation, of course, on all these boards, but then you also have class-leading Wi-Fi implementation. That's pretty cool. You then add in all the other points where you're talking about mature technologies like PCI Gen 3, NVMe support, of course, all that M.2, Thunderbolt 3 via adding
Thunderbolt
card
3
support.
really coming into its own too.
Yeah.
Yeah,
So
definitely.
all that stuff is kind of baked in there, so we're good to go there. So let's quickly just take a look at the actually
Yeah, let's jump in.
the topology map, and so you guys can just get a quick reference here of what this looks like in terms of the overall chipset. So we're going to cut over here to a slide. We're going to quickly show this to you, and for the most part, it looks pretty similar. You can see right here, you've got 9th gen, 8th gen CPU support, right? It's still dual channel base memory. 266 is the default in terms of the operating frequency. 16 lanes PCI Gen 3. This is the big difference really where you have compared to like B&H series. So it's designed for running kind of multiple GPU configurations or having complex storage configurations. So like 2 M.2 drives in a RAID 1, RAID 0, and a single GPU or however you want to cut it. Of course, you got the Gen 2, Gen 1, of course, USB 2, integrated gigabit Ethernet, and then of course your Wi-Fi implementation, and then of course your integrated display out. So all really kind of the key technologies. And down here at the bottom, while it is something that we started to see, of course, implemented in the previous generation, Intel Optane continues to kind of steam through as far as offering more and more options. And you had the 900 series, now you have the 905 series. So you have truly just amazing performing options that you have available to you. So whether you're going with a more kind of entry-level board and you want to be able to drop in one of those Intel accelerators, or you're going actually into a high capacity, super high performance Optane-based solution, of course, these are fully baked in and ready to be able to support that. So we can go ahead and cut back away from that, and let's keep moving things along here.
And so just before we jump in and we start focusing in on all the individual technologies, there are so many moving parts. There are so many improvements here, refinements there, Intel Optane with Intel chipsets, Intel wireless solutions, Intel routing solutions. When ASUS is looking at how they're positioning their products and their strategies, what kind of improvement report do you deliver to consumers? Because we're so far beyond a single benchmark kind of world, right? You can't just say clock speed, and that's the benchmark that everyone cares about. You can't just say like, with Intel Optane, you're not talking about sequential reads.
Yeah, you're talking about latency, you're talking about lifespan.
Exactly. So what is ASUS's challenge when you're trying to communicate this is a platform shift up the food chain for consumers?
I think the most important thing that we try to do is try to communicate the value proposition. For those of you that are watching this stream, whether it's your first time building a system or whether it's the 6th time that you built a system, what we're trying to do is helping you understand how our board technologies, in conjunction working with Intel and their engineering teams, help to maximize whatever Intel has done on the chipset side or on the CPU side. So that means if Intel has enabled really impressive overclocking margins, what kind of tools are we giving you to be able to have that experience be as turnkey or as robust as possible? So whether you're a simple user and you just want to be able to maximize your investment in an unlocked part, or whether you're somebody that is just looking for kind of a stable and reliable system, or whether you're somebody that's kind of jumping over from a build from 3-4 years ago and you're wondering about like how's this going to affect my storage? I want to be able to kind of run my games here. I want this type of experience. I want improved audio. So I think our job is to try to contextualize the features, the functions, and translate that into you as a user, right? Because while I definitely think probably most of you guys are gamers, these overall platforms, what they've done on the CPU side as well as what they've done on the chipset side as a whole is really catered towards, I think, a wide range of users. You have everybody from content creators, advanced productivity, gamers, professional science and simulation, doesn't matter. There's a board, there's a CPU, and there's a platform that is right for you. And so I think our job is try to convey that. And I think actually that brings us really well into talking here first and foremost about the new CPU specifically, right?
Yes.
So we said that there's 3 new CPUs. So we've got the 9900K, we've got the 9700K, and then we also have the 9600K. So in terms of your base clocks, most of these are all pretty similar on the base clock side. So 3.6 gigahertz, except for the 9600K, which is 3.7. The 9900K is pretty crazy in terms that it introduces 5 gigahertz turbo on 2 threads. So you've got 5 gigahertz. That's pretty crazy. Excuse me, single core,
Well, because
5 gigahertz
on this
frequency.
chipset, not only bumping up core count, but also delivering that frequency speed at the top end.
Yeah, and then you add into exactly like you said. So you've got that 5 gigahertz. You add in then 8 cores and 16 threads.
Right.
And then, of course, you're still working within relatively that same power envelope, 95 watts. Now, it's important to remember that the overall power consumption is in the base clock operation. As you go into, of course, turbos or overclocks, of course, you're going to consume more power. And that's where, when we talk about Z390 boards maybe being a little bit more tuned and designed for this new 9th generation series of processors, that's where there's some differentiation, where we've kind of gone back and retooled and redesigned certain elements of our power delivery system, certain options that we have available to maximize the fact that we've got such bigger, beefier CPUs that are now on the platform.
Again, because there's so much going on, a thermal change like that, as you're talking about a higher performance part, would affect, I would imagine, it would affect the design, the implementation, and the strategies employed in making sure that that's running as consistently, as stable as possible.
Oh, for sure. And for us, that's probably number one there. I mean, at the end of the day, ASUS boards are known for their stability, reliability, and performance, and we don't want to compromise any one of those. And so our goal is to always try to make sure that we're offering you the best experience in each one of those categories. Interesting also, Intel, I think took a lot of feedback from the community, and that for those of the enthusiasts that really care about it, thermal performance has been improved on the CPU side because of Intel's now reintroduction and implementation of a soldered thermal interface material for the CPU.
I wanted to pick your brain on that because I was going back through, we had notes, so obviously we were talking about some of this stuff before the stream. It's like we didn't just show up and make magic happen. I had to do some homework. Because I feel like a couple generations back, there was a trend for delitting certain Intel processors and certain Intel chipsets. Does this look like a direct commentary on the cooling and the performance solutions that people were using in the past, or is this just sort of like the normal path that Intel was probably already going to take?
Yeah, I mean, so it's not the first time that actually Intel has done this. There's been changes, based on kind of, different type of guidance that their engineering team has done. And it's very important to preference that, Intel was still able to reach impressive frequencies, and all the performance advertised, right, with their previous implementation. But I think what they wanted to try to achieve here, especially with the introduction of this Core i9 in the mainstream, and across the board, was to be able to say, hey, we're redoubling down and committing to giving the enthusiasts what they're asking for, right? So maintaining, really, truly outstanding core ratio multiplier overclocking, bus clock-based overclocking, an extremely impressive integrated memory controller, probably the best memory controller in the industry when you talk about the sheer frequencies that can be reached on this side. And so I think that they were kind of going, okay, on top of this, let's make sure that users that are making the investment in the highest tier performance cooling solutions, so 280 millimeter AIO solutions, custom water cooled solutions. You want to be able to make sure that you're not being kind of limited, right, between that interface heatsink material, right, and your actual cooling solution. So this helps to just maximize that overall efficiency. And the great overclocking capability of this chip isn't maybe limited in some degree because, you're talking about this CPU, you're talking about hundreds of megahertz that you can push clock frequency. So when you talk about being able to really improve that frequency, you don't want to potentially maybe be shaving that down by a couple of hundred megahertz, because of you're running into a thermal wall sooner than later. So for those of you out there, I think you guys are going to be really happy about that. All of them are featuring the solder interface material. I think beyond that, like we talked about on the PCIe lane side support, pretty similar as the same exactly not pretty similar, exactly the same as the previous generation with those by 16 lanes PCI Gen 3 support coming from the CPU, being matrix linked to the boards, the USB 3 Gen 1, the Wi-Fi. But one important thing to kind of keep in mind here on the CPU side that a lot of people kind of forget about that's also present in the boards and tie into the CPU is something called MEI. And so this is the management engine firmware. This is kind of like part of an overall instruction set that Intel defines and implements along with board partners in the UEFI BIOS. And this management engine, the MEI firmware really helps to provide guidance in terms of how kind of the processor should work most effectively and efficiently. And so Z390 boards come with this latest generation MEI firmware baked in, and all the rules and all the optimizations that we do from the ground up are designed specifically for the latest generation of 9th Gen series CPUs, where it's actually the opposite on a Z370 series motherboard. That board has management engine firmware that's from the previous generation that has been designed and validated for 8th Gen series processors. So all the tuning parameters are made for those parts. Now we do have the ability to, of course, add in code to allow for retroactive interoperability and compatibility, right? But you also have to account for kind of all that space and optimization. There's a lot of subtle code that we have to put in for a lot of different models. more people are going to probably be running a 9th gen part on a Z390 series board. So of course it makes more sense for us to do maximum level of, let's say, tuning efficiency and any algorithms that we have in play for those parts than necessarily optimizing them for
a better delivered native toolkit.
Exactly.
Yeah.
And so, what this translates into is, at stock, you should pretty much see parity performance, but when you get into kind of overclocking variability, Z390 might have a bit of an edge, along with then, of course, having that improved power delivery design and other kind of customization elements that we put in to be able to maximize that. So that gives us pretty much, I think, kind of the arc of, okay, we've got new chipset, 3 new CPUs. But I think it's important to also not just limit this conversation to understanding kind of the CPUs. Are they all overclocked? What's the DRAM frequency to support the PCI Express lanes? I think often overlooked, especially when you're kind of taking a look at the entirety of the ecosystem, is the underlying technologies that Intel allows for on these CPUs to be able to allow to be tuned and customized. And what I mean by that specifically is that we've worked very closely with Intel to feedback from our own engineering team as well as from the community that over the years has been introduced. An example of this is, let's say, like a voltage adjustment. So if you're an enthusiast out there, probably if you've ever tuned your system, you've used some form of voltage control to be able to provide more voltage to the CPU if you've been overclocking it. Intel has really been a leader in this category to be able to implement, you had your what's called static or manual vid, which was the kind of the granddaddy voltage option, and it still exists. A lot of users still use that.
Like what I was using back in the day,
as the default option.
What I'm most familiar with.
What that means by default essentially is that if I put in, for example, like 1.4 volts, right? That means it doesn't matter what my computer's doing. I could be sitting idle at the desktop. I could be reading an email. I could be watching a YouTube video. I could be checking out a stream, playing a game. It doesn't matter. My voltage is fixed. It's always running at 1.4. Yeah. You can, of course, realize with that type of implementation, what is it going to do? You're going to consume more power. You're going to produce more heat, and even potentially have some what might be called voltage degradation.
You were telling me that you're priming the processor, you're priming the chipset to be operating at that voltage, which means over time you could be degrading.
Correct. Yeah.
The internals for that, and then you'd find that you'd probably have to pump even just a little bit more voltage to match what you were doing.
Yeah, and now keep in mind it's not immediate. This takes time, and of course it depends on the amount that you're providing to the part. But it is something that you have to kind of factor. And progress came, and so after the static or the manual voltage, we then had an offset. An offset worked better, where essentially you could have increments of voltage applied to different steps. That still wasn't necessarily the most elegant, and for some people it was kind of complicated to understand these increments of an offset.
I remember when that arrived, and how many of us just didn't trust it.
Yeah.
Again, it's something new and different, so we're gonna react to that. But it's interesting that we didn't stay there for very long, but for while we were there, I'm just gonna go with like a static voltage, and we're just gonna go from.
And the other part to this as well is that there was merit to sometimes having a static voltage where, because maybe it was still a little bit early and it wasn't as responsive or dialed in as it could be, if you're at a high frequency and you need a consistent amount of voltage, if there's too much of a drop in that voltage, right?
Yeah, you're going to introduce
instability and crash. So there was still merit to that. But as things kind of refined and improved in the responsiveness of these different electrical components that could be put on boards, feedback from Intel, we now then stepped into something that has now been actually on boards for a couple of generations, but I think has really hit the sweet spot as you're now getting into parts that can reach such impressive frequencies, but also have such good what are called gating technologies where they can kind of drop down, right? And that's going to be what's called an adaptive voltage. And so this has kind of really, I think, been the standard that everybody's been looking for, because the really big benefit that you have with an adaptive voltage that's present in these CPUs is that when the CPU is operating in, let's say, its normal arc, so it's stock arc, right? You don't modify the voltage. There's no increase in the overall voltage. When the CPU reaches its modified or overclocked frequency, these turbo ranges, that's when the actual voltage kicks up. And so this allows you to really maximize not only getting the best performance from your system, but you considerably reduce the amount of the power consumption, heat production, even degradation or overall lifespan, right, to the part, is you're really minimally affecting the part because you're only lightly ramping it, just in those kind of key key situations when it's kind of going up, and then it can kind of come back all the way down.
And especially in an enthusiast situation, we're not talking about 24/7, 365
Yep.
red line operation. There's an idea that you'll spike here and maybe you'll stay there for a while,
Yep.
but we're not building these parts around like
Correct.
that kind of mainline operation.
And this also ties into I think overall user experience. By having less power and less heat being produced, it also allows your system to be quieter, so that you can have quieter operation for your system, especially if you have your system right next to you. And the reason why I think it's important to touch on this is because some of you might be coming up for older platforms where you didn't have these type of technologies, right? And you were concerned more about voltage, and you were concerned more about heat. You were concerned about these factors. A lot of these things have kind of disappeared, and we'll talk about some of our really impressive brand new AI overclocking technologies that we've introduced that to take direct advantage of this. So even if you don't know anything about this and you don't want to figure out how adaptive voltages work, you can still go into our motherboards and you can use our pre-built, inbuilt options to automatically overclock the CPU, but know that you're getting the latest and best and most efficient, effective ways of overclocking your system, right? Just by clicking a button, proverbially, right? So I think that's pretty cool, and it's something, like I said, I don't want to trivialize because it is a very impressive form of technology that right now, from a mainstream standpoint, there's no other CPUs on the market that offer an adaptive voltage policy adjustment. So it's pretty cool. So you pair that together, like I said, with the impressive overclocking capability for the CPU, bus clock overclocking, DRAM divider support, which is just absolutely insane, and now this voltage adjustment, and then everything we're baking in on the hardware side and the firmware side to tie in all that stuff, a very impressive overall part.
Yeah, because Intel's given us a great base. It doesn't mean we can't go farther.
Yep.
We should want to go farther.
Well, that's the whole point, for sure. If you're buying into Z390 and you're
Yeah.
buying a K-series part, you've bought essentially a platform and a processor that's designed to allow you to even take that amazing level of stock performance that you're offering and take it to the next level. So you really want to leverage that. And I think the last part on that performance side is going to be on the memory. So, in the previous generation, you were seeing memory frequencies that were kind of in that range of up to probably about 4,000 megahertz. And so Intel's continued to kind of refine the overall memory controller to allow for this. I mean, 4,000 megahertz in itself is pretty insane that you can now reach that. We've worked very carefully on our board designs for the actual topology. And so some of you guys might not know what these things are called, but if we bring up a board here, right here, this essentially area between the CPU socket and then your DRAM, these are essentially called your traces. And so these are super fine lives. These are signaling lines. And we've actually developed our second generation technology of something called OptiMem 2, where we actually have a ground plane layer. We have other optimizations that we've implemented here, which help to really significantly reduce the amount of crosstalk and maximize signal performance. The more that we can maintain that signal performance, especially at these really high frequencies, allows us to reach even higher and higher frequencies. So the thing that's really cool is that for this generation, if you're somebody that's really looking to push the absolute envelope and you're looking for the highest level of performance, not only from the CPU, but also from the DRAM, you're going to be able to see even faster frequencies. And the really cool part to this is even with full DIMM population. Historically, highest frequencies, especially for 4,000 megahertz plus, was really only achieved in single or dual channel memory. Well, not dual channel, but two DIMM configuration, not 4 DIMM configurations. So the fact that we're now able to achieve that even in 4 DIMM configurations, really, really impressive stuff. So you add to that another aspect again of that performance layer, where when you look at this overall platform, like I said, you don't want to just limit it to just like going, oh, Z390 has this Wi-Fi and this, or it's just enabling overclocking for this, or it's just 8 cores and 16 threads, right? There's a lot of things that's kind of the sum of all of this kind of together, I think really allows you to have a truly amazing enthusiast platform.
Now, for that RAM, was it just a situation with signal transmission when you're talking about that, or were there also thermal concerns there too for maximizing that performance?
There's not so much thermal concerns. Thermal concerns do come into a bit of it, actually at higher frequencies when they're heavy under load. And so what I mean by that is that most actually memory kits that once you get beyond about 3,800 megahertz, if you're talking about like 4 DIMM configurations, if they're under sustained heavy load, they actually do produce quite a bit of heat. And you do want some form of active airflow, whether that's like top-down airflow from the top of your chassis, or you actually have a direct memory heat sink that you might put over the unit. But for most gamers, the memory footprint is fairly light and variable, that you don't get a consistent kind of heat pooling effect. But if you're somebody that's doing more content creation, so let's say they're using like a WS board or they're using a Prime board, and they're, they load up like 4K footage.
Yeah.
And you've got like a
8K footage
like
these days.
or like a 20-minute timeline.
Right.
That might sit in like 32 or 40 gigs worth of memory.
Oh, yeah.
And you might be holding there for a long period of time. That actually frequency with that load, you could then actually have over a period of time where initially it might not have a stability issue, but after like an hour, because there's so much heat there, similar to CPU, you could actually have instability.
Gotcha. Okay.
So heat plays into it, I'd say, under certain configurations. And of course, the higher the frequency you go, the more relevant it is that you want to be able to keep it
But
cool.
when we're talking more about like the gamer and the enthusiast space, not necessarily, because I could pick your brain about WS. We're going to talk about WS.
Yeah.
I'm a workstation board kind of guy. Not that I don't love the spread, the sea in front of me right now. But if you don't mind, to elaborate a little bit more on what ASUS is doing for signal pathway, because that to me sounds a lot like some of those early challenges I faced in the world of like digital audio.
Yep.
Minimizing distortion, minimizing crosstalk, keeping channels and grounded elements separate, so that you've got the purest audio signal moving from point to point. This sounds like some of the challenges that you guys are working with extremely high frequency RAM situations, and especially getting into the overclocking situation on that too.
Yeah, so actually here I can even show you guys a little bit of a slide of kind of some of the actual physical design work. 'Cause
excellent.
This is something that we had to work extensively on. So here you can actually see the bottom of the large ground plane and then that ground ring. So the reason why, of course, you create this is it's similar to kind of like a moat, right? So you're trying to essentially moat any surrounding signals from
Gotcha.
impeding and affecting that. And so like, if we go back up here, where we can see right here, this reduction in the crosstalk, right? That's important. Why? Because at those higher frequencies, we have much more susceptibility to have instability at being able to maintain that high frequency.
Okay.
And so that's, if you're down there like at 3,200 megahertz, it's not a big deal, right? But when you're talking about 38, 4,000, over that, this is where these little things become that much more relevant, and where
Gotcha.
we worked really hard to be able to implement that. So the cool thing that you'll find is actually across all the boards that we'll be talking about here, they do
Excellent.
feature this OptiMem 2 technology. So that is it's a pretty sweet, kind of just like you just get that baked in. And again, that's a difference between Z390 and Z370 boards. Our Z370 boards have great DRAM overclocking, but our Z390, again, they're taking advantage of Intel made refinements in the memory controller. Let's even go further and maximize those refinements by physically improving our designs to allow you to even get a little bit more. So that way you can maximize that CPU overclocking experience and overclock that DRAM overclocking experience.
I love it. I love it.
So that pretty much brings us, I think, to, I think the majority of kind of overclocking, I'd say kind of covering the core kind of update that we have here within the mainstream segment, right? In terms of Z390, 9th gen processors, right? So we've covered 3 new parts. They're all overclockable, right? We now have a new high-end standard with that, of course, 8-core, 16-thread part, 5 gigahertz is achievable in turbo. We've got improved DDR4 memory support. We then, of course, have all those key technologies supported on the chipset side, NVMe, USB 3.1, 3.1 Gen 2, the Wi-Fi implementation, multi-GPU support, of course.
Of course.
And then, rounding things out, you got Thunderbolt 3 and then Intel Optane, right?
Yeah, so Intel's given us a nice little basket.
Yep.
Of parts and toys to play with, and I think we should probably start talking about how the amazing and creative ways that ASUS is taking that basket of goodies and manipulating what it is that we can do with it.
Yeah, so we get to now jump into it. For those of you that are interested, we're going to be talking about some awesome motherboards. So, I think the part that we talked a little bit about this before here is that for this platform, the part is so impressive that, of course, this can fit into a lot of different users, right? So we've got everybody from content creators, advanced productivity, science and simulation, to, of course, gamers, multitaskers, streamer gamers, right? All these different premises. And so at ASUS, that's really our kind of goal, is to be able to find kind of those different options that exist in the marketplace as far as user scenarios, and saying, okay, how can we design and develop SKUs that are really tailored for these specific users. So for this generation, we've got quite a number of series. So if we kind of go wide here, you won't be able to see them all here, so we're going to pull a couple into the frame here and give you guys some perspective. So first up, And this is just to kind of give you guys some context. We're not going to go into all the boards yet and their SKUs and the features and everything. Just letting you know the series that we have. So first we have our Prime series. So the Prime series is really, I would say, kind of like a jack of all trades, and normally you'd say the master of none, but it's really actually outstanding at everything. It's really kind of the quintessential ASUS board in terms of really being, it has a great overclocking experience. It's stable, it's reliable, it's got a clean, stylized aesthetic. Its feature set and software set has really been kind of designed to be able to balance across not only for gamers, but content creators and everybody kind of in between. So if you really don't know which board to pick, you can't go wrong with the Prime. It's an outstanding foundation. And also for those that just love that white aesthetic, it's a beautiful board with the white stylized aesthetic. And we'll get more into, its kind of unique attributes there. But that's our Z390-A series. Next here, we'll take a look at this guy. And this is probably, I'd say, along with the Dash A, probably by volume, our most popular SKU.
Okay.
And this is going to be the Strix. So the Strix series is going to be in our mid-range category for our gaming series of motherboards. They feature features and functions that are kind of derived from our flagship ROG series. They're part of the ROG family, but they are not our formal ROG branded motherboards. So it's ROG Strix. And these boards are really designed for users that kind of want to hit that sweet spot in terms of gaming. They want all the kind of key spec, they want stylized features and functions, they want improvements in audio and networking, they want good overclocking, but they don't want necessarily maybe to have more specialized niche, either aesthetic or specialized designs for like custom water cooling or modding or many other things that might get into more kind of specific higher end or niche type kind of category. Or maybe just when you go into ROG, sometimes it's just about pushing the envelope in terms of design, innovation, performance. So these are really a great foundation. These boards, we actually have two. There's an ATX board here, and this is the Z390-E. And then we also have the Dash I, which is the mini ITX version.
Far and away, Strix is already in the live chat with some of the questions they've been feeding us. People are asking about Strix.
Yeah, for sure.
Definitely, people are curious about that.
Actually, below the Strix, and still fairly new because we really only introduced it in the last generation, is now TUF Gaming. So some users that might be familiar with ASUS knew that we used to offer a TUF line.
Right.
And we had actually a branded series
We got
of
to
boards
talk about it,
that.
I think, that first time that you dropped by, we were talking about TUF. That's right.
And so TUF Gaming is really our kind of focus at being able to offer an ASUS design board that still has ASUS design quality, but then be able to offer something that's at a more aggressive price point. So these sit underneath the Strix series, but you can still see they've got a great stylized gamer aesthetic. They're still, of course, going to feature a huge amount of ASUS technologies that help to improve the reliability, interoperability. But we've also done a lot of things to be able to help to offer, I think, a really solid and stable, reliable first-time option. So we do a lot of extensive validation that while this board might not have maybe some of the higher-end elements that you're going to get on the higher end boards, you're still going to get a really solid, stable board. And we've also worked very carefully with ecosystem partners. As being kind of like a first-time board, maybe you want to pair this up with a chassis, a cooler, different types of components that will perfectly work together, right? As you get a more advanced user, you don't necessarily look at the sea of all the hardware as a negative. You get excited by it. But sometimes as a first-time user,
it's intimidating.
It can be like, I don't know which is maybe the right thing to get. And so here we have our TUF Gaming Alliance, so that if I go and I look, oh, this is a TUF Gaming Alliance chassis, cooler, power supply fans, I know that they all work together.
Well, and that is one of those conversations that I've had with people interested in PC building is they want to build a PC. You need to kind of build your first PC before you know what kind of PC you want to build. So it's nice to kind of be able to get your feet wet. All right, which one are we going to next?
Actually,
we can go WS.
We can go WS.
This is my baby.
And so WS is a series that doesn't actually get, I think, as much recognition as it should. But it's actually a huge segment for us. ASUS is really proud to actually offer a full division in our company that's dedicated to professional server and workstation-based platforms. This actually comes from that segment of our team. So this board, it's got a much more, I'd say, it's not a gamer stylized aesthetic, it's a no-nonsense aesthetic. This is about performance, clean lines, and really about giving you a huge amount of robust connectivity, right? So like even we can compare to these other boards, we'll get into the spec when we actually start talking about these boards, but you can tell this board has dual U.2 on there, right? Why? Because somebody in the professional space might actually be going and getting two Optane 905P drives and putting this on this, right? So you can just see it's a different class, but WS boards also, you can physically feel it when you
Yeah.
feel this board, the
It's
heft and
beefy.
weight of it, is they go through an extensive level of validation and interoperability testing for things like complex RAID controller cards, compute cards, right? High performance capture cards. Like probably on this motherboard, nobody's probably dropping in a $600 RAID controller or a quad gigabit Ethernet card or maybe a $500 4K multi-input capture card, right? Sometimes those cards have complex logic and they might not work correctly when you interface them into certain boards. You can run into sometimes these teething pains. And so with a WS board, we actually have a whole team that go through a really extensive validation process to check a lot more of these specialized components. Because the people that are usually building on WS, it's not just a hobby. You're doing it maybe as a profession, right? And it might be part of your livelihood or it might be part of your work focus. They make an outstanding choice for streamers and gamers as well, or anybody's just looking for an awesome, clean build. But we really have purpose-built these boards, to pair up perfectly with these highest performing CPU parts for those professionals that want to get into serious content creation.
I won't hang on that for too long, but I thought it was really funny when we were talking about like the different styles and aesthetics.
Yeah.
That even just several years ago, a workstation board
Yeah.
very rarely had aesthetic considerations.
For sure.
Like it's okay if your workstation board looks good.
Yeah, I
too,
think we
so.
really benchmarked that. When we started first, we shifted and we started making our WS boards with like a branded color aesthetic. We had a lot of those kind of content creators come back to us and actually they were really excited by it. They were like, they were happy to see something that was clean and polished and well designed.
Yes.
Because they came from that same type of background. And they appreciated that there was a distinct stylized difference compared to something that might have been branded as a gaming piece.
Yeah.
Because sometimes they appreciated all the hardware ingenuity and the innovation and performance that went into those products, but they're like, I don't want it to look that way. I just want something that's clean and professional.
Totally.
Right? But moving into, I think, this whole nother strata is ROG.
You want me to grab this guy first?
Yeah, so I think either one, because we're
Okay.
just using this as a spotlight to be able to kind of talk about ROG. So here, lastly, when we get into our series, is our ROG. So this is formal ROG. ROG is really the de facto gaming brand in the PC industry, and it's now over 10 years old, over a decade. And it really is about the benchmark. If you're looking for premium in terms of components, quality, performance, innovation, aesthetics, ROG is going to check that box. I think when you look at the board, it's absolutely beautiful, but you can tell that it's just been built for performance, but built to equally look amazing.
Yeah.
And whatever you want to
I'm even
throw
just
it
having
into.
fun catching the light in
Yeah.
our studio.
And so, if we pull quickly the formula just to kind
Yeah.
of show you over there, you can just see, kind of the evolution of the overall aesthetic. But hopefully this kind of gives you a perspective. We're going to now dive into actually some of the specific board level features here. We'll maybe quickly see if you guys have a question on these series as a whole.
Already got fingerprints on it.
Yeah, but you can tell this board is just in a whole nother class. I mean, just this is actually featuring the same metal Iridium finish technology that we pioneered and innovated on our Rampage Extreme Series motherboard, where actually we fuse the Iridium into the metal, which allows for a translucent refraction so that when the lighting actually goes onto this board, it actually literally seems like it's part of the metal and it translutes like it's underneath the armor. It's absolutely just breathtaking. And even by itself, though, this is the cool thing is that our ID team, when you look at that board by itself, it looks beautiful.
Yeah.
It just looks amazing.
even
And
just-
if you're not an RGB fan, it'll look amazing.
still look
by-
really cool.
It'll look amazing by itself. But if you want to have that next level experience by taking the lighting into it, you can totally do it.
But it's even just down to the little design considerations as to like what you're doing on the rear panel too,
Yep,
which is
yep.
just phenomenal.
Yeah, and this is where you can easily see that when you take a look at a board like this, these boards are really purpose built for the users that just demand the best.
Yeah.
Right. So recapping, Prime series, the ROG Strix series, the Tough Gaming series, the WS series, and our ROG series. So we have 5 different series of these series of motherboards for you guys that if you're interested in building a Z390 based system, interested in being able to take any one of those latest 9th gen series parts and be able to have an amazing box for whatever purpose, there's a board that's right for you. So before we jump into actually some of these design points where we'll start off with the Prime, any questions that we're seeing on maybe the segmentation?
Here, let me, while you start pulling that up, I'm going to look at, pull this back up here. And so, so we did have some questions first about just Intel 9th gen. Will these have hyper-threading? I think we're looking at the continuation of cores versus individual threads. So
Yeah, so there is.
we're still going to be doing fine there.
Yeah, so that's a good question. So let's just reference the exact chart here, right here. But pretty much what you've done is there is a bit of a change that we've had compared to the previous generation. So hyperthreading only exists in your highest end part. So the 9900K is going to be your hyperthreaded part. So that's 8 cores, 16 threads. Actually, we don't have a slide for that. You guys are looking at something else there. We'll get in a second there. But it's, yeah, only the 9900K has hyperthreading. So 8 cores, 16 threads. When you drop down to the 9700K or the 9600K, it's a pure logical
One-to-one.
core set.
Yeah.
So 8 cores or 6 cores. What I will say to that, though, is that the overclocking margin is absolutely amazing. So not only do you get just a native monster in terms of having 6 cores or 8 cores, right? But then I'm actually really, I think I might be most excited. The 9900K, I think a lot of people are going to absolutely love on that, especially if you're buying in a high-end part. But the frequencies that I think you're going to be able to see on a 6-core part, which I think is a perfect balance at giving you a reasonable thermal balance, even on something like a 240 millimeter AIO type cooling solution, or like a Noctua U14S or something like that, or U12S, is just going to be awesome. And 6 cores for the vast majority of general users, so browsing, some editing, some photography, browsing, gaming, that's a sweet spot because you've got enough cores to be able to manage the vast majority of games and clients, which are sitting between that 1 to about 4-core mix, and then you still get some additional multi-core flex, right? Because you got 2 additional cores, right? So you get a nice bump up in multi-core based performance. But clock speed is always king. So the fact that you can ratchet up that clock frequency and you can hammer it up while also having those cores and not at the expense of dealing with the additional heat envelope that you're going to have to manage when you get into 8 cores,
Right.
or even hyperthreading. This is, I think this is the, if you guys are into cars, this is the sleeper, right?
Okay, so what you're saying is like from that enthusiast perspective, we could be looking at the potential for a little more headroom on getting to that upper limit.
For sure, yeah. And this has generally been the case. I mean, definitely, the overclocking frequency number is even what Intel's already demoed today in their press event. You can go online and see some results that they've done on liquid nitrogen already that they're kind of soft previewing, although there's a more performance information that you guys will be seeing later on in the month from Intel on these parts as well as from everybody. But they're all, I can tell you that they're all fantastic overclockers. And the overclocking experience, I think, is actually, in my interpretation, in my experience, along with the fact that you've got this solder interface material, it's amazing. It's the best Intel overclocking experience I've ever seen. I'm just really excited about that part specifically because it hits a real, I think, outstanding sweet spot in terms of its cores to kind of relative power and heat to then also how much I can keep pushing that frequency envelope.
We do have one more question about 9th gen, and this one kind of getting into the security and the privacy aspects of our chipsets. This is from Shane Shepard on Facebook. Can I assume Meltdown Inspector vulnerabilities have been mitigated in the 9th series?
So Intel has pretty much already patched all of these through generally software updates and management updates that were executed. So all those are already baked in. So essentially all the Spectre and Meltdown updates that have been issued for 8th gen and for Z370 based platforms are also present here. Since architecturally this is pretty much the same as 8th gen parts except for some changes in terms of that core and that frequency optimization, a couple things like that. There's no other changes beyond that fundamentally, but they've essentially been able to leverage essentially all the work at those security resolutions and put those in place.
Now, so what it looked like to me was that over the time period from the disclosure of Meltdown Inspector, we've also been seeing those improvements from all chipset manufacturers, from all processor manufacturers, that the early batch of fixes were where we saw some of those heavy performance deficits and that we've been able to minimize
it's continually been improved, right? And this is a conjunction effort on all parts, right? Because there's some stuff that's come from Microsoft, there's some stuff that comes from the boards, there's some stuff that comes from the CPU. So it's everybody working in tandem. And overall, even with all that, you can still see the performance number that Intel's advocating that these are unquestionably the fastest parts that they produce. So even all that withstanding, you have amazing performance.
Excellent. All right, so let's get into these boards. We got to start talking about these boards.
So quickly here, we're just going to touch on, we're going to focus on the Dash A as being kind of our key SKU that we want to really talk about. For those of you who are interested, we will have Three kind of other ones that will be, I think, of a lot of interest to you. We'll have a SKU that's a little bit lower end, a little bit more entry in terms of the price point with the Dash P. And then for you guys that are micro ATX enthusiasts, we will have a M Plus variant. So if you want to go into the micro ATX. Give me a second here. Let's go ahead and prop this board out here, and I'll get over to my first slide here. And we'll let you guys get a quick shot of this here again. And so we'll talk about the aesthetics here while I get this slide lined up. So first things first, you can see it's a clean, white, monochromatic, stylized aesthetic. I love white on motherboards, not only because it looks clean, but it's great actually for RGB because the actual light reflects off of it, as opposed to on black boards, it actually gets absorbed. And so even if you have a lot of light, sometimes it can get lost a little bit, but here it will really be present. This whole area right here lights up. The board, of course, fully supports our ASUS Aura Sync technology, so that means it can control and synchronize with, of course, everything from DRAM modules. Here we have the T-Force Delta RGB DIMMs in white, which look beautiful. To of course you could do things like SSDs, chassis with LED lighting. We have now Philips Hue support, so if you have ambient Philips Hue lighting in your room, it can be synchronized with the RGB lighting.
I really love hearing that, like IoT starting to play nice with that lighting setup. That's really cool.
But overall, I think the design and the aesthetic really looks nice. So I think it's going to work perfect for any of you that are going to be looking for, like I said, a clean, kind of stylized look, right? But that doesn't necessarily may have like the darkness or maybe some of the more stylized accents that you see on our formal gaming kind of motherboards in terms of that aesthetic. So one of the big things that we're going to be talking about here on these kind of series of boards, and this will apply really to all these boards when we're talking a lot about these features, are going to be kind of key technologies. So one is going to be the power delivery design. So right here at the top, you see your VRM assembly. And so for those of you that don't know what the VRM is, essentially that's your voltage regulation modules. So those are your power delivery components that give power to the CPU when the CPU gets overclocked. These components are made up of things like your capacitors, inductors, which are sometimes referred to as chokes, and then your MOSFETs or drivers, or in some situations, you have improved components which are called power stages. Power stages actually unify the MOSFET and the driver together and allow for better efficiency and generally better performance. So for this board, this is actually a big update. Generally, the Prime series have usually relied on high quality two-stage solutions, so that means we have a MOSFET and a driver package. For this generation, because of the additional power demands and also wanting to give you better thermal performance and overall better performance, the Dash A features actually an integrated power stage. So you get very, very good performance in that regard. The other thing too is the heatsink design. This is actually quite a robust, it's a finned multi-stage heatsink, and actually I'm going to pop something off here in a moment. So let me go ahead and show you.
Doing it live.
One cool thing that our thermal engineers carefully tried to look at and kind of try to analyze was trying to maximize surface area. So a lot of times people make an assumption when they're looking at a heatsink and they just look at the top and they think that's the only part that dissipates. But you can actually have a lot of flexibility at how you approach.
Well, I skipped over a question in the chat because I figured we would get to this. Someone, let me see if I can find it. Someone asking about, well, what about all that plastic? Won't it trap heat on your motherboard?
Yeah.
And this is exactly what you're discussing right here.
So yeah, there's multiple parts to that. For that question, there's actually, you guys won't be able to see it, but we do actually have, like you see here, a staged intake. So you can actually see that it's not directly covering over that. So we started allowing for space. You could argue that maybe if you removed it entirely, you could get even better airflow. But keep in mind that the thermal threshold tolerance for these components that we're using are extremely high. So the fact that we're still adding that additional airflow room, right, is already still helping to improve that. But if we take a look here at this heatsink, and we'll show you guys here a slide in a moment, but first I just want to show you this heatsink, is that there's multiple surface areas. So here you have the top. If we pull to the back, you're actually going to see those individual like kind of thin little fins that are there, right? And then you're of course going to see multiple stages here, right? Which that allows for, of course, more points of dissipation. So you have to think about the heatsink and the entirety of its design. A new thing that we've also done for this generation and significantly improved thermal performance is that we can see that we've done actual thermal pads for heat conduction for both stages of the VRM. Generally, almost exclusively, you have never directly made contact with the inductors. So your power stages generally usually run hotter than the inductors, but the inductors do produce heat. And so what I mean by that is that this pad right here, there's one pad and then there's another pad. So one pad makes direct contact with the actual voltage regulation modules, and then another pad makes contact with the actual inductor. So that means we actually can pull away heat from both those components. And that actually gives us significantly better overall thermal performance for our VRM design. In addition to that too, we also feature a digitally controlled design that allows us to do balancing for these inductors. So we can manage things like we can decide, we can look at the temperature per all the inductors and we can balance the power distribution. You can set it for if you want to prioritize power versus temperature. We can do a lot of things also that it's not just how you look at it. There's a lot of configuration parameters depending on how you want to tune and run your board that allows us to maximize the performance of that. So this is really cool because again, like I said, we won't recap on some of these things as we get into the higher end boards because the higher end boards are going to have it.
Yeah.
You know, they'll have even cooler heat sinks that we might talk about, but we won't recap some of these things because we're starting off at the entry, essentially, kind of like our Dash A.
What was
you know,
ASUS's
and has this.
conversation with consumers? What motivated that stage here? Is it because of what Intel is trying to accomplish with 9th gen? Is it hand in hand?
Yeah,
with...
it's a hand in hand because I mean historically, I mean ASUS has really always been a leader. You know, we own more overclocking performance crowns than any other vendor that's out there, and year to year we've always spent a huge amount of time to design and develop and thermally qualify our solutions. So it's not like us going back and saying, oh, we needed to change anything. It was just about continuing the mindset of always having what can we do to maximize performance, especially for this type of platform that has so much performance capability.
Nice.
So if we switch over here to this slide, we'll give you guys a little bit of this kind of close-up shot. Here you can see the power stages, right here, there's your inductors. Another cool thing right here that you might not see easily, and we'll show you on a wide shot of the motherboard when we come back to it, but we'll finish with this slide here first, is that the actual physical connectors, the wiring inside the CPU power connections are actually physically increased. They're thicker gauge, and that allows us to actually have better performance. Think about it kind of like speaker cable, right?
Yeah.
Thicker speaker cable performs better. It's the same type of scenario here, is that this allows us to actually have improved current performance with lower temperature performance actually at the contact because there's not as much resistance. And then here you can see the thermal padded interface for the actual VRM heat sinks. So this is kind of the core part of how we've looked at saying how can we improve the power delivery design. So whether it's bringing in the power, whether it's the power on the motherboard, whether it's the OptiMem technology, right, the digital power delivery and control, you can feel really confident that this type of board is going to give you great experience. And just for you guys are wondering, this is where that ProCool interface, it's way too small to be able to show you, but that's why we gave you that kind of little close-up shot right there in terms of that. So give me 1 second here to go over to our next little shot here. We'll talk about it. So this is another really cool thing. So you can see right here we've got these 4 DIMM slots. Now one really cool technology that we've also baked in, which is going to be, I think, hopefully really appreciated by users, is something that we've had in previous generations. And it's a little switch right here. You won't be able to see it. Oh, there it goes.
You got it.
Yep, a little switch right there. And this is actually our MemOK technology. So we've had MemOK for years, and we had a physical button on the motherboard that you had to press. The disadvantage, though, with any motherboard button, though, is the reality is that you only have access to the motherboard when you're building it.
Yeah.
Right? Once inside of a chassis, do you really want to have to go inside your chassis to press a physical button, right?
Cue video of like infomercial, black and white.
Right.
How do I use my hands?
Right. How do you, exactly. So now the cool thing that we've done here is with MemOK technology version 2, it's a physical switch. So as long as it's in the on position, it will automatically do its job.
Gotcha.
So pretty much you just build your system, and what it's doing is we have essentially a special chip built on board that's monitoring what's called the post routine. So the power on self-test and memory training. Memory training is essentially when the CPU, in conjunction with the motherboard, is looking at the memory and trying to figure out how do I make this memory turn on and work correctly. In our analysis, actually, one of the most common points of failure, or let's say issues within building a system, tends to be memory related. And so what the MemOK chip essentially allows us to execute and do is that we have the ability to make adjustments. So we can modify things like voltage, frequency, certain sub-timings, certain variables to essentially get you up and running.
Yeah.
So that if your system wasn't maybe compatible, or maybe even one of those DIMMs was marginal or having an issue, we can make adjustments that allow you to get into the UEFI and either tailor things further, or maybe it actually will just fully work, right? Or maybe there's a newer UEFI that comes out, right, and you bought a kit of memory with an older UEFI. So you bought this board, and this new kit of memory comes out 3 months later, but you've never updated your thing. You pop it in, right, and it doesn't post. Well, now we can get you back beyond that issue get your board updated, and then you can get up and running.
That really does seem to be a trend moving into, again, not just clock speed, not just more cores. We're talking about better observation and management tools.
Yep.
And because there are going to be a few other things that we're going to be talking about here too in terms of managing overall system performance and system health.
Yep.
But that this is going, again, out of a single benchmark, instead of just, well, how hot is the computer running?
Yep.
And I remember when that was just like, the internal temperature of the box measured, I don't know how, but you'd get one number. Now we're starting to deliver more recognizable and granular performance data that you don't necessarily have to manage yourself, but you can if you want.
Yep.
But in a meaningful fashion that takes into account all of the various technologies that are being tied together.
Yeah, and I think just, the main thing that we're trying to execute here is this is generally what we include as part of our kind of experiential improvements, right? ASUS boards are really known to be kind of that leading turnkey experience that if I build it, hopefully everything just works. And so while we validate actually with more memory partners than anybody else in the industry,
You can't account for everything.
Exactly.
Yeah.
Well, and there's things that are new, right?
Changing.
Yeah, so there's stuff that's just always adaptive and kind of evolving. And so this is just a way of helping us to provide an additional option to you when you make the investment in an ASUS board. You're going to have just that next level function that will hopefully help to enable a better or more reliable experience. So
Nice.
That's going to be pretty cool that you have in addition to that. So in terms of kind of just some of the physical layout stuff that you would expect, of course, the board has got dual M.2 on there. You've got an M.2 heatsink, of course, because latest generation of the high performance drives. You got something like here, like a 960, the 970s. These really high performance drives, they're awesome, but they can produce a bit of heat, especially under sustained load. So the heatsink just helps to ensure the best overall performance, even under the load. You'll see that we follow our design conventions where we really try to be careful and considerate, with the exception of one on the WS board where we took an even more advanced heatsink solution because of the positioning placement. All our boards, we never try to place it underneath the by 16 slot, because that's where GPU pooling occurs, or when there's generally the hottest part of your system. So you can see here the M.2 is down at the bottom, and then we have the other one which is directly on top of the by 16. So you have more kind of optimal positioning. This board is also going to support our Thunderbolt 3 add-in card. So if it doesn't come with Thunderbolt, which would increase the cost of the board, but if you want Thunderbolt 3, you can get our add-in card, drop it in, connects to a direct header, you're good to go. It's got improved audio, improved fan controls, improved networking. We're going to touch on some of those specifically in a moment here.
Yeah.
But I think the big one, probably a lot of you probably are wondering about now, is probably a bit on overclocking. So,
well, this is what I was teasing in talking about better management and optimization tools.
yeah. So, when you get into overclocking, right, we talk about all three of the key SKUs that you've got for this platform. They're overclock-enabled SKUs. So, there's always a lot of challenge when you approach overclocking, right? Either you fall into a couple of camps. Either you're a first-time user and you don't know anything about overclocking. Two, you're kind of like a marginal kind of user where you've maybe done it every kind of once in a while. You kind of know some of the general kind of some of the terminology, some of the overall theory on how to overclock, but you haven't done it consistently, right? Then there's also those set of users, they're dyed in the wool. They're like me. Every generation, they dive in, they get the boards, they spend time in the forums, they watch videos, they read the manuals, they're asking questions, they know all the different aspects, and they try to maximize, right?
They buy liquid nitrogen.
Well, I don't even consider that as part of the three. Those are in a whole nother camp, and we make boards that work
There is
great
a
for
board
those
for
guys.
that. Yeah, definitely.
Yes, but
that's not
But
what we're
from our
talking
normal
about.
user basis, I think you fall generally into one of those camps. And generally, our feedback that we've had from most people is that people that don't do overclocking, even when they buy a K part, which is crazy because you're buying an overclocking part and you're buying an overclocking chipset, it's because fear. I'm going to break something. It's going to blow up. It's not going to work right. Two, time consuming. It's just, I don't have the time to sit there and figure this out, and I don't want to do it, right? And then three, it's just kind of like a general kind of combination of all of them, right?
Yeah.
It's like fear, it's time, it's the knowledge investment, it's kind of all these different aspects kind of just rolled up into one. And so we've long kind of been a leader at trying to really implement a lot of auto-tuning technologies to be able to offer users a more turnkey experience. For this generation, though, we've gone back and really rewritten everything that we've done, and we're introducing something brand new, which is our AI optimization, our AI overclocking technology. And so what really makes this unique is that we've kind of rebalanced the implementation to be equally beneficial to users of any one of these segments. So whether you're a first-time user, whether you're a moderate user, or whether you're a seasoned dyed-in-the-wool enthusiast, our actual implementation can provide you information and value that will allow you to maximize the investment in the motherboard that you're making, in the CPU you're making, and the cooler that you're making, your whole system. And even I think more interestingly, and something that we've never offered before, is offer a real-time adaptive adjustment to your overclock based on your scenario. So
because Intel's core design is already making the argument for variable voltages, variable clock speeds.
correct, yep.
So now
within the arc of stock performance.
exactly, and now we can take that and build on top of it.
Correct, and so that's what we're kind of doing here. So we can't get into the entire nitty-gritty of this because, of course, we still have a performance embargo here, but we're going to give you guys the nuts and bolts of how this technology really works. And so what will essentially happen is if we actually could shift over to a slide here. Now this is going to be, of course, within the operating system, but this is 100% available to you within the UEFI environment. So you'll actually have something that's called our TPU Insight that works in conjunction with our AI optimization. And there'll be something that will be assigned in terms of a target frequency and then cooler points and then silicon quality. We can go ahead and pull away from that slide now. And what we're essentially doing there is that when you jump into the UEFI, the slide will look, the graphic will look a little bit different, but we'll know essentially which CPU you have in there. We'll estimate essentially based on our internal testing what the projected range is for that clock frequency.
Right.
And then we will actually tell you what these clock frequency targets are. So this could be, let's say, theoretically, we'll use a lower frequency just as an example, but 4 gigahertz, and we say you can get to 5 gigahertz, right? We'll tell you the difference between you being able to get to 5 gigahertz for an AVX-based load and for a non-AVX load. The reason why that's important is that AVX exists in some applications and in some Windows services that use .NET Framework, where many games and general applications do not use AVX. So sometimes you want to be able to condition your overclock for those two different variables. We will tell you that information. We will tell you the target voltage. So again, if you're just a manual tuner and you just want to know, oh, I just want to get to this, we'll tell you that exact information. And if you want to go manually and dial it in, you can do that. You can even put in your own target. So if you're going to try to manually overclock your system, you could put in your target frequency. So you could put in 5 gigahertz, and that chart will adapt in real time and tell you what your voltage should be. So it's almost like a crib note or a cheat sheet that's based off of analysis that we've already done that gives you all this information. Now, where things become much more intelligent, though, is while all this is happening, the moment that you prop in your processor into the motherboard, you post into the operating system, it will guide you through and it will tell you, please run a game for an extended period of time, run a stress test. Why? We're tracking the temperature from your system from idle to load in real time. And that actually will get assigned a cooler value in terms of a certain amount of points. We have this broken down from kind of entry-level cooling solutions all the way up to custom high-end custom water cooling solutions. Of course, the higher the water cooling solution, the more points you get accorded, because that means you have more thermal headroom and you can also allow for higher voltages. And once this is measured within the actual TPU Insight, within the AI optimization suite, you will be presented with essentially your target overclock. And it will tell you, okay, we think you can get to this 5 gigahertz marker. Click this button, we'll restart, and it will automatically apply that. That's all you'll have to do. Now, like our previous generation, you will have the option that if you want to run a stress test to your system after that overclock is applied, you can entirely do that. Or if you want to run your own, feel free to do your own after that. So we make this extremely easy, extremely fast, extremely simple, and extremely reliable. But the most impressive part, though, is that the monitoring does not stop after the overclock is applied.
This is definitely what I was hoping you were going to break down, because it's great to see information gathering up front. I mean, you could make your, well, I mean, if you know what's in my system, you should know that, like, oh, well, a 9900K should be able to overclock around here, so you can build all that in. But
it's important, though, to not to interrupt
really
you there.
measure, yeah.
Well, it's important to note that every CPU is different.
Exactly.
So, every CPU is different. Every board might have some difference in terms of how it might be able to hold the load, and every cooler would be different. So, while we give you that target range, that's where it's still important to be able to monitor these things as well as run that stress test.
Yeah, because your system actually did this.
Correct.
Now we can make those adjustments. But above and beyond that, your system, a year after you build it, is not the system that you started with.
Correct.
And so maybe even from improvements in cooling, or maybe you're just like me and you never close loop water cooler. and you should.
Yeah. And and this happens for a lot of reasons. Even if you're good about maintenance,
Life gets busy.
Yeah, I mean, I've got 3 dogs, right? One of my primary systems is on the floor. My dogs love to come and lay in my room, and chill back. And there's no escaping the fact that hair gets in gets in places. So that can actually affect thermal performance. Or again, we're here in California. I'm inland in Upper California, and our summers last summer. We were seeing temperatures easily, they were exceeding 100 degrees. And even if I'm running my AC, your ambient temperature goes up. Why is this important? Well, we're tracking the temperature. And if we see that the temperature is actually going higher and your overall cooling performance is coming down, we can actually drop down your overclock, even without you knowing it, because we're trying to adapt automatically, use that kind of that AI predictiveness to be able to go, okay, hey, we see a reduction here. Maybe we should drop this down a little bit to be able to maintain the performance. But this is customizable by you. If you want to go in and define your own target intervals, like how often the system is looking at the overclock, you want to dial in the thermal threshold range. All this is customizable. So again, this could be as simple as a user just dropping in their CPU, going into the operating system or going to the UEFI, clicking one button, rebooting, and getting an overclock, and having a big investment being returned, right, by having a stable and reliable, faster system, right? If you're a tweaker and tuner, you got a great baseline of information to be able to start and work from and be able to customize and
a continued conversation.
Exactly. And if you're kind of in that middle ground, you can play around with it. Maybe, you kind of start everything off and then you go, okay, we don't auto-enable XMP, so then maybe that manual user still goes, okay, I got my overclock, now I'm going to enable my XMP, maybe I still want to play around with it a little bit, but we did all that initial work for you, and now you just did a couple of things versus having to kind of spend hours and hours and hours trying to figure everything out. So this is a really, really impressive technology. We've been working on this for a huge amount of time. It will continue to get refined and improved, of course, through more firmware updates and software updates, but this is going to be a big part of the ASUS Z390 Intel 9th Gen experience. It'll be on our Prime series motherboard, our WS series motherboards, our Strix series motherboards, and our ROG series. The only boards that will not feature this are going to be our Tough Gaming on that entry level. They still will 100% fully support manual overclocking. So if you want to go in there, and they will still offer some basic kind of preset-based overclocks that are a little bit more minimal, where you can just kind of click on something, you get a little bit of an overclock range.
The general idea.
Exactly. So you will still have some nice immediate turnkey options, or of course manual options available to you. But if you're looking for this really robust AI optimization, AI overclocking implementation, it's on any one of those series I just noted. So a very, very, very cool feature.
No, this is really exciting because I think it was around 10 years ago, if you'll pardon the trip down memory lane, where we were starting to talk about some of these machine learning algorithms influencing design. Like there was an experiment in London of trying to design new circuits. Just by brute force, we'll send a computer to just go and see what's going to eventually be the most efficient circuit. NASA designing an antenna, I think roughly around 2010, 2012. Through this kind of machine learning and how long it took and how iterative that process was, that we've now finally arrived at a consumer-facing solution which has an operational mode which is near seamless, which is completely in the background. Now, on top of that, why do you think that there's still, in some communities, that little bit of a ghost of an issue, or a ghost of a stumbling block when it comes to a software overclocking solution?
I think a lot of it, to be honest, is just a misunderstanding of the implementation or an assumption. So even just calling it software overclocking is technically incorrect, because it actually is executed from firmware. So it's actually done on the same level of you doing your manual overclocking. So you're using the same firmware environment, and then we're leveraging the benefits of what we can do in the operating system. The operating system is relevant because the operating system is required to place a load onto the processor when it's under its turbo state, so that it actually ratchets it up.
And I've never, you can overclock all day long, and eventually you're going to have to put
you have to put
some
a load.
Software,
and that's why any manual overclocker will tell you, if I put in a value, it's only once I reboot and then begin to go into Windows that I get that lock or that crash if my values aren't correct. So we try to weave that all in together. So, and I think also, we've already proven this wrong. I mean, tons of users in the community, media, have shown that our auto tuning technology is really class leading and equally as impressive as somebody that's manually overclocking. But for the users that haven't tried it, there is still that kind of that general trepidation of, everybody else in the industry, we're kind of got thrown in the boat with them. That serves us a disadvantage because our tool was unique. It was different than what everybody else was doing, which was just presets. And some of those presets didn't really work well. They were inefficient. They weren't necessarily always reliable. They didn't account for the silicon lottery. Because a preset, the way it works is, the engineer samples a whole bunch of CPUs, puts in just a predefined target, and then the disadvantage of that,
should be able to do that.
That predefined target might work well for a certain set, but if you have a really good CPU or if you have a really bad CPU, worst case scenario, the bad CPU won't even post with that preset.
Right.
It'll just crash.
Bounce.
And then a great CPU, it works, but it's doing it at maybe a higher voltage with less efficiency, more heat, more power being consumed than it needs to. I can show you guys quickly here just a little bit of the slide.
Definitely.
Just so you guys can see what it looks like here in the UEFI environment, where you can see the actual prediction values that are in here. Like I said, in our advanced boards, you'll have more options where you can go in and you can customize it. There's a full guide that walks you through all this if you really want to read every question. If not, you just click the button, reboot, and you're good to go.
I really like that. Just click the button.
Yeah.
Just go.
So we try to make it as simple as possible, but then for those of you that want to take the time and be able to get that information, you can. So why don't you quickly say if you have any questions on that, because that's a pretty cool feature. If not, we'll keep jumping this along here.
Yeah, definitely. Here, let me scroll back down through here. Well, actually, Stefan Weiland just wanted to mention that ASUS is always good at RAM optimization. So he just wanted to leave that comment there for you.
Thank you, Stefan. I appreciate that. I heart your heartness.
We do have a question, just to backtrack a little bit. This is from Kataria. Sorry if I'm mispronouncing your name. I'm bad at names, so if your name is, I'm probably going to butcher it. And so I'm just going to apologize once up front, and then I'm going to let it go. How about telling us how much power the VRM can deliver? How many amps output? How much temperature does it put out doing it? Is there any commentary on that from?
So we'll definitely give you more of that information. I would probably recommend you actually go, because that would take a pretty good chunk of the time from here.
Right.
I can definitely tell you can feel confident that in the overclocking capability, even going down to our Prime-A, that the inductors and the power stages that are present there are not going to limit you in terms of your overclocking experience. Your question, though, it becomes very specific because the inductors or the power stages between one board may be different to another.
Yeah.
So like on the Formula or the Hero, they are going to have even higher end inductors, or there might be differences in capacitors. Like the Prime might have 5K capacitors, and then that board might have 10K rated capacitors.
Gotcha.
So those numbers are going to be variable, so we can give you that information if you want to be able to get down to that nutty level. And there's definitely nothing wrong with that, but you can feel confident that as you go up in the board stack, you are going to get significant improvements in those components. But it's also important to note that the thermal performance of those components is also influenced by the heatsink assembly. So if we go back over to, let's say, something like the Formula or the Strix
Grab
board.
this guy right here.
Yeah. You start to have significantly more advanced heatsink assemblies. So this is a huge, massive copper block heatsink assembly, right? That works exceedingly well even when it's not actually using water. This board actually supports a custom water cooling loop where you could even cool the actual VRM assembly by just taking these off, connecting your actual your tubing to there, and you're good to go. And you directly water cooling the VRM. The cooler you keep any component, the better its overall electrical efficiency and its performance.
Yeah.
So when we look at higher end boards, like the Prime has a very good heatsink, but we'll see that the Strix heatsink is bigger. The Maximus Hero is also bigger. It has more surface area. So it's not just the power components that are getting improved, but the heatsink performance is also even improved further, helping to bring that power component to even a higher level of performance. So it's a little bit of a loaded question, but definitely you can feel confident in the overall output performance of any one of these power components.
Because we have a question from Kylie Crystal, and I think this is going to lead us into the next part of our conversation. Anyway, talking about she has an H100i, and also working with 9900Ks, and ASUS's solutions for incorporating those different types of cooling technologies.
Yeah, so we're actually going to just start talking about cooling. I tell you, anybody that's got something though in the 240 millimeter class kind of closed loop cooling solution, you are going to be bang on to have an amazing experience with these parts. Like I said, especially in that 9600K, 9700K, you're going to definitely be able to have very, very good performance.
It just makes me happy how excited you are about that 6 core though.
Yeah.
Because so much of the conversation is going to be like, oh yeah, 9900K, 9900K.
Well, it's awesome.
To watch you kind of light up a little bit.
I just like to be able to push frequencies, so I'm really excited by that. But in addition to that, the solder interface materials also significantly help to bring consistency across all the core temperatures and bring the temperature performance actually lower than it would traditionally be if it wasn't. So that in play with a great thermal solution is actually giving you really good temperatures. So overall, actually, I find that where in the previous generation 8th gen parts, especially if you started to get into the higher frequencies, you definitely started even to need almost triple AIO cooling solutions. Those will definitely still be advantageous for this generation, but I think a lot more users are going to get even better performance from their 240 millimeter and 280 millimeter cooling solutions this generation, especially if they use like our AI technologies and they use adaptive voltages as opposed to like static voltages and stuff.
Nice.
But speaking of fan controls, if we go back again here to our Prime, but it doesn't really matter because it's present on all these boards. When you look at a motherboard and you're talking about kind of the overall, let's use the Strix here.
I'll hold it for you.
Yeah, we're talking about overall kind of thermal considerations. When you go plugging in all your fans into the motherboard, you've got, of course, a different set of headers. So the first thing that really influences this, and not a lot of people realize, is that there's actually, it's not just the physical headers. You could put a 3-pin or a 4-pin header, but you actually have to have a physical chip. It's called a Super I/O controller chip. That chip's job is to manage the actual controls for the fans and interface that into the firmware or into the UEFI BIOS. So ASUS has really been a leader in this category, really setting the benchmark. We implemented our Fan Expert technologies. We've had them for years. And our most recent progression has been Fan Expert 4. Well, what does that mean? A couple key things. One, the fan headers that are on here fully support 3-pin and 4-pin fans, so DC or PWM. Well, why is that important? PWM output support is important because if we talk about most chassis, you know, a lot of chassis now you have 2 or 3 front fans on the front intake, right?
Yeah.
And then maybe you've got 2 fans for your radiator. Well, the cool thing is even though a lot of our boards have tons of fan headers, if you have PWM output, and most now fans that you're getting on the market for cooling solutions are 4-pin, they're PWM, you can use a cheap PWM splitter cable. You don't have to get a chassis or a fan controller hub or controller. You could just literally get a splitter cable, you plug that into the header. Once you plug that into the header, it could have like 3 outputs, right? You can plug 3 fans into that, and all 3 fans will receive that control signal from that one header. So that's great because let's say your front intake fans connect that to chassis fan header 1, right? And all 3 of those fans are now grouped together in a clean, contiguous control.
You don't need to have
I don't need 3 individual headers.
Headers for that front-facing cooling solution.
Exactly. So that's a huge benefit that you have with PWM output where you don't have that option on DC. So in addition to this, though, we've also done some other really cool things. We have our fan calibration and control technology. This is in the UEFI BIOS, so even if you don't want to use our software, you don't have to, but it's also in Windows, where you can click a button again, and we will analyze the minimum speed and the maximum speed of all your fans. Why? Well, maybe your chassis came with 1 or 2 fans, maybe your Corsair cooling solution came with 2 fans, and then you bought 3 other fans. Well, guess what? Every single fan has their own actually unique characteristics. One might be a max of 1200 RPM, another one might be 1800 RPM, and maybe the other ones are 2100 RPM.
Right.
So actually analyzing all of them to know what their minimum and their maximums are helps to make sure that when you actually use the fan controls on our motherboard, not in the software from some other solution, we can actually control all of those fans to their correct characteristics. And also our what's called extreme quiet mode will work effectively. And what that means is that we can actually ramp all the fans down to 0 because we know what their minimum operating value is. That's great because like if you're just reading your email or watching a YouTube video, your fans don't need to be spinning. You're not producing heat. So why not just have pure silence?
Because no, I really appreciate that. It's just the first time I worked on a workstation that the fans all just turned off.
Yeah.
That was that moment of discon. Wait a minute, what broke?
Yeah. And keep in mind, you can of course, you can adjust that all you want. So if you don't want it to drop down to our extreme quiet mode, you can, of course, adjust that. You can customize the fan curve. It's all available to you. Another really cool thing is something that's called temperature input mapping. So traditionally, if we talk about a motherboard, if you plug in, let's say, your chassis fans, so let's say for your front intake, which are bringing front intake flow into that system, here's a graphics card, right? That's bringing direct airflow to the graphics card. Well, does it make sense that the fan should be only responding to the CPU temperature? Probably not, because if we use the Casey's H100i as a scenario, that CPU is actually probably running really cool, especially under gaming. I doubt that CPU is probably breaking 60 degrees.
Yeah.
The GPU, though, is probably running quite a bit hotter.
Yeah.
But in almost all traditional situations, especially if you're running boards from years ago, 3, 4, 5 years ago,
you're pulling the temperature from a general
only
case.
from the CPU. That's it. what we can now do on these generation of boards is you can map them to different temperature sources. Take, for instance, maybe the motherboard or the M.2 drive or the graphics card.
Yeah.
So the moment that that graphics card is ramping up, you can have your intake fans ramp up. But then if you still want, of course, your CPU cooler to respond to CPU temperature, you can do that. So you have multiple temperature input sources that are all available to you. And all that control is just really awesome. And again, like I said, it's all available either in the UEFI or it's available in the operating system via our Fan Expert software. So, you know, in addition to that too, also, there's dedicated headers on the motherboards for things like water pumps or AIO pumps.
Well, I wanted to talk a little bit more about that too, because this is something that again, in the enthusiast space, they're ahead of the curve. But now in general consumer spaces and workstation spaces, water cooling is not a scary endeavor
it's a par for the course. I'd say in this segment, probably more users will be using some form of an AIO, not custom water cooling, but they will use an AIO water cooling solution to cool their CPU. For a Z390, it's going to be the lion's share of most users. So the great thing is here is that if you're wondering where to plug in, you can just find the AIO header, plug into that header. Now, not every cooler will work that way. Some still will use maybe like a SATA power connector, may vary. But if it uses a header for its power for the pump, then you can just plug straight into that. You don't have to worry about like, oh, I don't know where to plug it into. So I can show you a quickly shot here what that kind of looks like here. You guys check out this slide. And you can see here we have kind of these grouped headers. Each one has its different temperature input source. We've got the AIO and the water pump headers. You can see here we have dedicated header for the M.2. So if you want to have an M.2 fan that's responding to the M.2 temperature, along with, like I said, that heatsink, you get really great performance. Actually, this is something we hadn't talked about yet. We're still on the cooling bandwagon, but this is actually a cool thing too, is that Z390 also offers support for Radeon CPU support, and this is actually our Hyper M.2 expansion card, which is compatible with all our boards. So if you drop this in, you can put 4 M.2 drives in one card and stick that into a PCIe slot and just have insane performance. So that's actually a configuration I've tried out in one of my home builds where I've got well, I had a 280, I had a 1080 Ti, want to upgrade that now to a 280 Ti, and then put this in the secondary by 16 slot as my primary driver array with 4 drives. That's just gonna be a monster.
So when you did that, what did you do? Would you RAID 0 or?
Because I have a NAS-based storage configuration system that runs imaging, so I don't care about. Normally, I actually don't advocate for RAIDs because of the potential failure point that you have. But as long as you have a backup solution in play, then
go for it.
Go for it. Why not? But continuing on to the theme, one of the last really cool things here on the fan controls and technology. And I wonder, I don't know if I'll have the box to be able to show you guys, but there is a header that is on our motherboards. Let's see if I can find it on this one. It's all the way down here on this one. And you won't be able to see it, guys, but it's called our EXT header, so it's our fan extension header. So the really cool thing about the fan extension header is that, let's say you got your 5, 6 headers, whatever here. Maybe you just want physically still more fans. What we sell, you can get it on Newegg right now. I think it's about $20 or $25, but you can plug it into there, and it will give you 3 additional fan headers.
Okay.
And the great thing is it's got cable flexibility because it has a cable, you can mount it anywhere you want, attach your additional 3 fans, but they're all still seen by the BIOS or by the software.
In the same way.
So it's literally just like getting 3 more headers physically for your motherboard that you can set up. And it even has 3 more temperature sources. So you just got insanity in terms of being able to kind of go to town.
But again, we want to find those ways where we're improving the granularity of the information reporting, of the system health as a whole, and not just for the sake of a one benchmark solution. I really like seeing an approach to system longevity, system stability, and then for those that want, go balls to the wall.
Yep, for sure. So that gives you guys, I think, when it comes to cooling, you guys are covered. We'll touch on some of the crazy stuff on cooling when we get to the RG board in a little bit. Because keep in mind, Fan Expert 4, again, just like our AI overclocking technologies, applies to all these boards. Audio. This has always been a big focus for us. I'm a huge audio guy. absolutely. I spend more money than I probably should on terms of audio, but I was a really big driver to help us design and implement the isolated audio path. We were the first vendor to ever do it. Now it's become par and course for the industry.
I can definitely attest to his individual perspective in the music solution that he also carries around. So
my goal was really, when working with our team, was to say how could we maximize the codec and be able to ensure that it had its highest level of performance.
Yeah.
And so, we were still kind of talking about Prime. I'm just using this WS here as a reference to talk about the audio design, but all the boards feature our isolated audio path. What essentially that means is that we've just isolated the audio section independently from the rest of essentially the board. That helps to minimize noise and maximize the codec's performance. Pretty much all of these are going to be using the S21220. On the higher end boards, they'll actually, on the RG boards, we're using the S21220 along with an ESS Saber DAC that's built on board. You've got audio grade capacitors, an operational amplifier. The difference really in the sound package is going to be that on boards like our Prime series, they're going to come with a nice software package from DTS, where we have DTS Headphone X, which actually is a pretty impressive stereo to surround bass
yeah,
DSP.
it's creating like a 3D sculpting environment.
And it's actually, compared to many ones in the past, it's actually quite good, and it's very customizable. We have targeted profiles for different types of music experiences, whether it's in music, movies, or in games. So it's really well suited to kind of everybody. When you get into the RG boards, those RG boards are going to get crazy, and they come with Sonic Studio 3, which has extensive audio control and customization options, which work really in conjunction with the advanced technology there. One really cool thing, though, that we also have on the Prime board, and with this Crystal Sound 3.0 design implementation, is something that we call headphone impedance detection. So there's actually a special circuit that we have built on board that when you plug in physically your headphones, we can help to measure the actual impedance of your headphone. And that's cool because if you don't know really about headphone impedance, but you just bought headphones, they can really vary. If you're probably spending usually between, let's say, like $50 to $200, which is what I would probably say is in the segment for what people probably would buy for these type of motherboards, it's probably going to be anywhere from about maybe in the low 20s all the way up to maybe about like 250. If you're beyond that, you're probably a really serious user, and you're probably buying like an outboard amp with a DAC and stuff like that. But in that range, you want to be able to adjust your op amp to have a certain level of driving voltage and overall performance for that. And so the great thing is, if you don't know any of those things, don't worry about it. Just plug in your headphone. You'll get a little pop-up that says, we've detected your headphone operates at this level. We set it for you, and you have the correct output performance for your headphone.
Yeah, there was one specific smartphone that started doing that made me silly excited. And then you start questioning, like, why haven't we seen this technology sort of make it into other consumer avenues? Because there's the notion, you're like, oh, I've just got a killer amp. So, but then you go and plug in like some consumer-grade earbuds, and you're just instantly overdriving that solution.
Yeah, you want to be able to match and ensure that you're getting that right balance along with that design. So we think we've done a really good job to be able to offer a really solid audio experience. Of course, there's still definite value if you want to get a discrete card. We make them. We have an entire line of really nice higher-end discrete cards if you want to get even better audio, but really great built-in option for a lot of users there. So let's quickly, I think, round out some kind of cool little things. Might be some last things before we kind of go into some of the Strix and ROG here and picking at some of these things. Is some of you might not realize some design improvements that we have on boards. Taking a look again here at the Prime. We actually are pretty much the only vendor right now that uses stainless steel plating for our I/O. You might not think this is a big deal, but it's actually more expensive. A lot of the other vendors use tin or different types of metal. The reason why that's important is you have oxidation, humidity-based issues. Over time, you can actually even get short or grounding issues. But with stainless steel, we don't have that. You have overall better wear performance. So again, depends on where you're at. Maybe you're like in Georgia, you're in Texas. Of course, there are other parts of the world, but for our US viewers here, where you have more ambient humidity, it's nice to actually have something made out of stainless steel as opposed to a metal.
I did have a buddy's board in Florida start corroding.
Backplate there. It does happen. Depending on where you're at, it can actually be a legitimate issue. So we have things like this. We do implement ESD guards. You won't be able to see them. They're really, really small little diodes that we sprinkle on actually all these headers. So they're directly behind the actual back I/O, as well as on our USB ports. These are part of our safeguard design, so that when you go and plug things in, if you're getting like a electrostatic discharge from, let's say, a flash drive, it's the most common thing you plug in, the board can essentially absorb that and minimize essentially having
impact to the rest of the system.
Exactly, as opposed to it flowing through. Because USB, a lot of people don't realize, the USB is all controlled by the PCH here. And so if you get actually a short signal, what it does is it goes, and then it goes, and it could short this whole thing out. So if you didn't have ESD diodes, you could go plug something in, and then the whole thing just shuts down. And you're like, well, what happened? I don't know what happened to my computer. And so we have a lot of preventative designs that are built in to help to safeguard your system. In terms of that regard.
Safely disable and safely unplug your USB devices.
Yeah,
Kidding, that doesn't have anything to do with what he just described.
And another cool one that we added in for this generation is actually the Ethernet ports. These right here on the back of the boards, we also are now using an improved, actually what's called SMT production. It's a surface mounted technology. It's produced by robots so that we have more surface area where we can put ESD diodes and other things in for the LAN ports. And that actually helps to protect that because actually you can get surges and spikes through the actual Ethernet port. So it can actually damage that port too. So on these boards, we really tried to look at all the different areas. So that's just things from like our reinforced, safe slots on these motherboards where you might not see them here.
Well, I was going to ask, because I noticed that on the data sheet for the WS. Is that something that's across the whole line
Yeah,
too?
the safe slots on any board that you see essentially that safe slot designation, it's present. And really for most users, it's really not a concern. They don't have to worry about it. All of a sudden the slot's going to break or anything like that. But,
some of these graphics cards are getting
yeah,
pretty beefy
especially with the 2000 series now, we moved back. It's feel like I'm going back to years ago when we used to have 3-slot cards. We're almost back to 3-slot cards. There is a lot of weight. And if you maybe move your system from place to place or go to like LANs and things like that, it is nice to know. And unlike actually some other design implementations that are out there in the market, our design implementation is unique in that this is actually injected molded. So if you actually kind of look at it, you'll see that the actual metal is part of the entirety of the actual slot design. Some vendors kind of will plate it on top, and so it adds a little bit of rigidity improvement, but it's actually structurally not entirely been improved. Our goal is that when we measure this design is to improve the Z, Y, and X axes. So any which way, what's called the shear force or the torsion force is improved so that it really is quite a bit more rigid and reliable. One other cool thing too, before we get into the ROG as Strix is, a lot of you guys that when you're building a system, you've had the pain point of like, not that many people use optical drives anymore, really. Right. I still do it because I actually do I
still have a Blu-ray burner.
I have one because Blu-ray is still for me the highest quality standard. It's the best bit rate, the best image quality. I do still use it actually for mastering files, ripping certain things because I still actually even buy some music on CDs. And so I like having optical media. But if you build a new system, you don't have an optical drive, well, how do you download the drivers? You always run into this pain point. We've implemented actually a new technology that we call QInstaller or ASUS Grid on our motherboards, where actually we kind of have the baked-in LAN driver present for you, and you get an automatic application that opens in Windows that will then allow you to download every single driver in real time. So it's a very simplified experience for you in terms of being able to get up and running with any one of these boards.
Yeah, the Blu-ray thing's still worth it if you've been following some of the iTunes news, where someone moved and their region had different support for the media that they downloaded. That's also, I think, at least worthy of discussion in terms of physical media.
Yep.
I'm just saying.
Yeah, no,
It's not
100%. So I think that gives you guys overall perspective.
Yeah.
We talked about the Prime here. A lot of what we talked about totally applies to the TUF Gaming series. Really all those main things. Really the main differential is, you're going to have some differences in the I/O spec. You can check out the boards right now on newegg.com or go to usa.asus if you want to get all the specific spec, or if you have a question on a spec, pop it in and we'll see if we can answer it for you. But it's going to be, some ports will come with a little bit more USB ports, or they'll come with maybe additional SATA ports or things along those lines. But a lot of the key technologies we talked about are consistent between these. TUF Gaming, though, compared to the Prime series, where on the audio specifically, they both have the isolated audio, but this one does also come with TUF Audio, which, while it's not the same Sonic Studio that comes in there, it's a little bit more of a customized game-centric version of software than the DTS software that comes included with the Prime series.
Okay.
And
of course, AI overclock.
Yes, and AI overclock, which is not present on the TUF Gaming. So I think here we can get into ROG, and I'm just going to use the dash I as my reference because this is just so awesome sauce. This is so cool.
I love that it's an entire motherboard in basically just the form factor of the panel on the back.
Yeah, I mean, this is
pretty ridiculous.
It's a beautiful board. You'll see, like with all our Strix boards, we're following our same consistent kind of design patterns. Clean monochromatic color scheme. So no colors to contend and compete with the look and feel of your build. Just like everything, Asus Aura Sync support, of course, on here. This is featuring more of our premium design touches, so you have an integrated I/O shield. You're going to see this on the Strix boards and on the ROG boards. This is fantastic because it just simplifies the build experience. You don't have to forget to put in, I didn't put in the I/O shield. But also a lot of people don't realize us pre-integrating this actually also provides significantly improved ESD performance. So this actually has better contact. So if you're worried about things like ESD and EMI, the actual I/O shield, a lot of people think it's just there to kind of protect you from not plugging something in right, but actually it serves a specific purpose in terms of ESD and EMI. And we get even better EMI and ESD performance because it's pre-fitted and allows for better sealed contact.
So we did have a question from Arthur Del Rosario about the housing for this and concerns about it fitting in a current.
So that's actually a great question. We actually have spent a lot of time. We actually have what we call our no zone clearance design. I don't know if I have the slide up here. I'll see if I have it. But we actually carefully provide our design framework, and we cross-check that with chassis partners to make sure that we don't have structured limits. And so what that means is that the X, Y, and Z axes are measured so that if you're going to put like in a closed-loop water cooling solution, the pump housing fits. Or if you're going to have a cooler, this doesn't impact where the cooler is going to sit or meet into. So these are all things that we vetted. So pretty much for most intents and purposes, for any, I'd say current generation and for last 2-3 years of current components that are out there, you shouldn't be running into any type of mechanical, I'd say issues in terms of physical installation. And we've done also a lot of other things intelligently. Some vendors have now adopted our similar design approach, but some vendors would used to bring the CPU socket down or they would play with weird spacing here. But here, in actually the space position that we put this in, we make sure to give enough space so that if you use like larger coolers, it doesn't hit the graphics card. So it's actually separated in terms of maximizing this. One really cool thing that you'll see on this Strix-I, we're not covering a lot of the key spec, but this board is packed in. You've got the integrated 811 AC Wi-Fi here. Remember, this has the 160 megahertz support that we talked about here, right? But it's got dual M.2, which is really cool. So if you want to pack in even 2 of these M.2, well, you're going, well, where do I put the other one? Well, one right here with your M.2 heatsink, and then just turn it over. just turn it over. And then you just have another wonderful M.2 slot. I don't have a button that sings for you, but it's song worthy.
That has been such a wonderful adaptation, getting away from the traditional hard drive form factor.
Yeah, it's great. I mean, I still don't agree with people where they go just like, oh, everything should be M.2, because there is merit to not only the capacity and cost that you have with SATA, but U.2, a lot of people negate it because they think, oh, well, M.2 is just inherently better. M.2 has specific limitations that people don't understand, that it was designed for laptops, which are power restrained and thermally restrained.
Yeah.
So that's the reason why the 905P, let's say from Intel, is not using M.2. It uses U.2 because they can provide more power and they can also have a larger heatsink to be able to produce more performance. So U.2 is still kind of, I think, creeping in, but M.2 has continued to expand so well that it's still making up that not only the share of the entry, the mid, and the high end, where now kind of U.2 is maybe only falling into that super high end, but I think we'll see a little bit more over time.
So a little prediction there from JJ about where we might see this trend head.
Yeah, to go. But you've got everything really you could ask for. You got 3 different RGB connectors on here, Fan Expert, awesome DRAM overclocking capabilities. It's all set in here. So with the Strix here, really the main improvements that you're going to get on this board is a lot of it's going to be in the software. Actually. Gotcha. So outside of course, I'd say physical improvements like the heatsink design, or maybe let's say aesthetics for RGB connectivity. Like most of the Strix boards are all going to come with usually 2 to 3 different types of headers, both digital and non-digital RGB headers, where like the Prime only had 1 header, right?
Gotcha.
So you're going to get some improvements in that regard. But it's going to be in the software. So while
totally fit right in the front there.
Yeah, maybe you check a question here. Let me see if I can bring up this slide here and give you guys some reference.
Get this here. Actually, Jimmy Kaufman, what water cooling would you recommend for a Strix board?
I'm a fan. There's a lot of different companies out there. I'm really a fan of tower heat sinks. So like I love like a Noctua U12 or U14S. But if you did go with the cooler, actually I really think you don't even need to go 280 millimeter. So anything 240 millimeter, which you can get from tons of different companies. Deepcool, Corsair, NZXT, Vantex, or of course, if you guys are feeling Asus, we are going to be launching the Ryu AIO cooling solutions, which are of course Aura Sync compatible. probably this month. So
Oh,
you
nice.
know, you'll be able to pair them up with your Z390, and they're going to look perfectly
Excellent. All
good
right.
together.
You got to hear first. That's excellent.
So, you know, you guys can check those guys out there. So one thing that we didn't talk about in the prime header here, but we can show you a slide which is pretty cool. And this is going to be on most of our Z390 series boards. Sorry, let me just make this a little bit bigger for you guys. Is right here is this is our new node header. So the node header is pretty interesting because it's a new header that we've built onto the motherboard that gives you the ability to essentially have a direct connection for a number of peripherals that have not yet been developed. So this is a brand new interface header that we've essentially designed and developed to be able to interface not only with accessories that we produce, but also accessories that are going to be developed by partners.
Gotcha.
So an example right here that we'll be able to show you is by InWin, or we have another partner, FSP, who makes a power supply, where it can interface directly in with that power supply and then allow you to have full control and monitoring of that device.
Nice. Okay.
So you don't have to worry about like proprietary USB headers or this type of different cable. You can connect it to the node and then all of a sudden have a full readout and full level of control. And so you can,
which is interesting that we haven't had that kind of reporting in power supplies.
yeah,
like
well,
such a-
you've had it in power supplies for a while, but it's all happened usually through some USB form of connectivity. Right here, let's go ahead and show you guys this little slide right here, and you guys can actually see this. So the cool thing right here is this is from a prototype chassis that we worked with InWin on, and this is, you can see right here, it actually has CPU temperature, could have frequency, could have a lot of different values that are reported that are shown directly to that.
On that front face.
So we'll continue to work with more partners, and you're going to see more of these devices and accessories become available. You know, like I said, not only from ASUS, but also from other partners. But I think this is a pretty cool option that you're going to see on a wide range of our boards, on ROG, on Strix series, as well as even on our Prime series board. So a very cool kind of next level kind of, I'd say, way to be able to kind of define and control your system. So it's not just monitoring, also control that's really the critical part. You'll actually be able to control and configure some of these devices. So it's going to be pretty cool, and you'll see more of these node-centric devices, like I said, as we probably get to the end of the year.
Nice.
And then, of course, way more as we get into
Well, definitely the
2019.
idea of the life cycle of a system, trying to account for what future technologies we might be able to incorporate.
Correct. Yep, for sure.
Nice.
So lastly here, we can kind of jump into, again, the audio. So we can check out the slide here where we talked about on the ROG series boards, the Supreme Effects. And so here you can see kind of a close-up shot of a lot of those components. So the switching MOSFETs, the Nichicon capacitors, the gold plating right here. And then, of course, that ESS Sabre
I've
DAC.
become such a big fan of that DAC.
Yeah, it is. It's a great DAC.
It's a
got
monster performer.
It's got a good level of tonality to it, nice warmth. It's not overtly bright. It's got really good performance in terms of working with a wide range of applications. For us, really the goal was trying to be able to, I think, elevate that overall experience. What we've seen in feedback from users is that they don't just use their systems for gaming. You know, they're listening to their music. You know, whether it's downloading HD tracks, you know, Spotify, whether it's Google Music, it doesn't matter. Or they're watching YouTube videos. I think audio has just become a key part of the overall experience of how we use our systems. And we just wanted to be able to really elevate that overall experience.
And it's something we often take for granted on, is like, yeah, this is functional. And I think now we're seeing an enthusiast base that's starting to demand something better than just functional.
Yeah, for sure.
Yeah.
You know, beyond that too, with the Sonic Studio software, there's really cool functions that you have built in there that, you know, we won't be able to demo them to you, but
Soon though.
you have some really cool stuff, like you can do post-processing and noise filtering for incoming and outgoing voices. So if you're in Discord, TeamSpeak, Ventrilo, Steam Chat, whatever it might be, and you're getting noise coming to you or you're getting some noise going out to you, you can apply post-processing, you can clean that up. You can apply matrix stereo to surround-based effects to actually different inputs and even different applications. Like maybe you want surround mixing on your game, but I don't want surround mixing on my music.
Yeah,
right. So you can go in and all these items are customizable in Sonic Studio 3. So definitely for those of you that are kind of like in that bandwagon of like, I'm not really a fan of software, I definitely tell you, take the time and look at it, because also on these ROG boards, we've got a huge amount of software set in there that's really, really, really valuable. Like we've got RAM disk and RAM cache software.
Yeah.
So you can create actually a whole disk made out of system memory. So if you've got like a 32 gig or 64 gig kit worth of memory, take 8 gigs, 16 gigs, and make a drive that you run your whole browser from, where you install a junction drive and map your maps for your game to run through, right? You got a lot of flexibility. Or RAM cache, which will work in conjunction with any of your drives, even NVMe, PCIe drives, and help to accelerate and stabilize the performance of that drive. All this stuff is only exclusive on our ROG or a Strix series of boards. So it's a really big value proposition, I think, that we add to allow you to maximize the hardware investment. Because, you know, if we probably compare a Prime user to probably a Maximus Formula user, right?
Right.
The Formula probably is dropping a lot more in memory and density and frequency, right? So we're giving them more software to let them leverage, you know, the improvements that they're making in that regard, right?
No, I definitely found even productivity boosts in using RAM disk and RAM cache.
So one board that I'm going to show you a picture of here that we don't have, but it's pretty crazy. So let's pull back out that Formula.
Yeah.
Because with the Formula
like holding it.
and the ROG series, this is BC. So, you know, here, you know, some of the unique things that you have outside just the aesthetic, and we talked, of course, already about the integrated EK cross-chill water cooling technology, which is just absolutely amazing. The brilliant, beautiful color, you know, on the RGB, and of course the customized MVCM screen. This also has dedicated water cooling connections on here, so you can do things like monitor temperature inlet monitoring. You can water flow monitoring that are built onto the motherboard. You don't need an external device. So these are pretty cool. Now, there is even a board that will be above the Formula board. And for those of you in the know, that's the Extreme board. So we don't have the Extreme board to show you right here. It's going to be coming in the not too distant future.
We've been getting comments asking
but I'm going to show you
about-
guys. I'm going to show you guys a picture of it. So let me pull up a photo here of the board, and then I'm going to also show you, you know, a pretty cool new design implementation. So here, if we can just switch out to this, and you can see that board. It's an absolutely beautiful board. You can see it's got the full side profile RGB lighting. RGB right here, and even subtle things that we've done with the RGB boards, like we did an offset ROG eye, so that means even like when you have the GPU, you're not covering the eye,
Right.
you know. You got the live dash display, which you can of course customize, right, and all that stuff. But right here, you see this DIM.2 design, right? Well, we had the DIM.2 in the past, right, that was the vertically implemented slot that you put your M.2 drives on, right? So we went crazy, and we made this guy right here. So this is the DIM.2 with the integrated heatsink module. So now not only do you get the ability to get the vertical airflow from the intake, airflow from your chassis, but it's also still got the heatsink. So that's going to be an absolute monster in terms of that overall design. So very, very cool stuff. And let me see here. You guys can see right here, here's the DIM.2, right? So you got multiple points on that Extreme board where you can still mount one M.2, two M.2, 3 and 4. So you got M.2 just like crazy, right?
I heard you like M.2, so we put
so-
M.2s on your M.2s.
Yeah, so you know, when you take a look at the ROG boards, you are seriously built and designed for just that highest level of performance, you know. So whether you're talking again,
It's just a monster.
you know, if you took a look at the back I/O on this board too, be pretty cool here. We'll put the side by side, just the kind of the comparison here, Formula and the Hero, and you can just see how the Formula even goes even further. Formula features dual LAN, which is crazy. Where not only we have the Intel NIC, but we also have the 5G based network interface card, and we also have our Game First Packet Priority software. So the really cool thing about the Game First Packet Priority software, we can go ahead and set that back, is that this new generation
wanna hold on to that?
Yep, is our Game First 5 technology. And the really cool thing that we have now is a really advanced real-time automatic engine that will detect all the different services that you're running, automatically profile them. We have one-click buttons for extreme bandwidth allocation. So if you just want to make sure that that program is getting all the bandwidth, you could set that, you can customize it, or you can let our database, which you can submit end-user flags to, which is really cool too.
Okay.
So if you know maybe something's getting flagged incorrectly and you want to say, no, this is a game, or this is this, or this is this, you can customize that either manually or let our database know and to keep automatically managing these things. But we've also done some really cool stuff that if you pair this with ASUS hardware,
Right.
we can even give you an even better experience. Our Game First 5 technology now works with any of our ROG Game Boost related routers, where it will automatically prioritize a detected device
was gonna ask
as the
about that.
primary gaming device.
Yeah.
So if you've made an investment in a cool ASUS router too, we're automatically pairing them together so that it sees it on the network and you get the highest level of bandwidth
Just sort
performance.
of drop that Chromecast a few,
Yep.
steps lower.
Yeah, and you don't have to worry about anything. So it's all built into a really nice, clean user interface where you just detect the router and you click on one button and you just have your login information, and it will automatically have the router go through all its quality of service. Normally, it can be confusing for some people to know, like, I don't know how to change the quality of service or prioritization options in my router. You don't need to worry about that now. Just
directly from the system.
The software, all it needs is just your username and your login information to your router. It logs into that, makes all the adjustments, and now it handshakes so that the moment you jump into gating, GameFirst notices this, and then you could even see all this information in real time because we now have an overlay menu for GameFirst. So if you want to be able to see all your information, your bandwidth, all that in real time while you're playing your game, you can see that. And so this is again where we're talking about that the software package along with the hardware is so much more evolved for the gamer when you jump into something like an ROG or a Strix Series board, as opposed to like the packet priority software that we might have on the Dash A or the Tough Gaming, which are nice. They still allow you to have some control and customization, but it's
you're investing in this. You want to be able to take it to that.
Exactly.
Next level.
You're just not going to that.
We did have a quick question from Nick Smith on YouTube. Can you confirm if DIM.2 will be available to buy on its own?
So actually, DIM.2 is a proprietary interface that we have to physically design and implement on the motherboard, right? So the motherboards that come with DIM.2 essentially will come with the DIM.2 riser card inside the box.
Nice.
Right? And that's also nice, like the fan extension card, you get that actually included with our higher end boards inside the box. So a lot of reviewers don't even give us credit, but it's value add that we gave you because it's already inside the box. Like the Dash A won't come with it inside the box, but you buy like a higher end ROG board and it will actually be inside the box. So you get a lot of those kind of extra value points.
Perfect.
Last couple little things here, most of the boards will have it, but you've got the USB 3.1 Gen 2 header, which is on, these motherboards, which you're seeing in more of these chassis as well. And so I think, that for the most part really covers the lineup as a whole. The last part now here, we've got a little bit of fun stuff to just tease on with X299 and the ROG Dominus. But, we'll continually see if you guys got any questions here. But overall, I think, just some really cool stuff, recapping the boards. Actually, so let's go ahead and cut to this slide here, and I can actually show you. I can show you guys actually what the GameFirst software looks like.
I think we're going to throw that back up now.
Okay. There we go. So here we were talking about how, of course, that on that board you have the support for the Maximus Extreme and the Formula featuring the 5G and the 10G base chipset support, which is awesome in addition to the Intel NIC and that GameFirst packet priority software. And if you want a 10G switch, we do make 10G switches now too. So for those of you that were wondering, how do I connect my systems together if I want that, we do have that available to you. The 160 megahertz, of course, Intel wireless module, which is built on board, absolute monster in terms of performance, just beastly. Here you can see this is the redesigned front user interface where you have the option to be able to customize different modes. You can go into auto or manual. Networking monitor, which also will give you a full real-time breakdown of which applications are using bandwidth, how they're using bandwidth. We have even a built-in wireless networking monitor. So you could actually see all the wireless channel spaces that are being used in and around your house, so you can pick maybe the right one, for your router configuration if you're trying to set things up like that. And like I said, down here, you can see also the monitor, and the overlay that we offer that gives you that information in real time. The integrated connection for the GameFirst packet priority software. Here's a cool quick shot of the actual integrated cooling solution on the Formula, the Crosschill EK3 version 3, where you can actually see the copper water channel, which you just don't see it because the board, of course, covers that
that's absolutely design. Crazy that it's built right on top of the board.
But it's built in here. You can see the reduction in the thermal performance from the dual heatsink design, and just the overall insane fan connectivity that you have on these boards. Here you can see the Maximus Extreme is just beastly, and it will also continue to use the water block sensor, which I don't think you're familiar with our water block sensor, but we custom designed a block sensor that we worked with partners on so that if they make a custom water block, they can actually mount it directly to the board, and it interfaces to give them all the control, like temperature, flow control. They get all the metrics.
Again, something that I feel like some people might be concerned about or anxious about if there's not standardization.
Right. You just get all those kind of different points. That temperature input mapping that we talked about here, you can see it's also shown very clearly in the software UI, where you can just map between the different temperature targets, right? And these are those water cooling headers that we talked about for flow monitoring as well as for temperature sensing. And here's that integrated where you can see leakage, temperature, and flow. So for people, they pick up that Extreme and they want that highest level of connection, you're good to go. And there's that extension card that we talked about. So pretty crazy stuff. So I think moving a little bit on from Z390, let's quickly just
Yeah, because we've been
touch
teasing
on
it.
here.
We got to mention it. We got to
Let's
talk
touch
about
on other two really big updates as we're getting ready to close out our stream here. And thank you for all of you that have
Yeah.
joined into the stream and checked this out. But Intel also made formal announcements today for the latest generation of X series processors. So for those of you who are not familiar on the X series side, that's X299, and that's HDET. So this is the high-end desktop. So this is now pretty crazy. You're going from the entry level being your 8 cores all the way up to 18 cores, right? And 36 threads, right? So absolutely just monster platform, you know, same level of PCI Express lanes as that we had before. And of course, you now have quad channel support up to 2666 in terms of the overall frequency. You know, of course, the big stunner, I think, for a lot of people is going to be that the 9980XE, right? So 18 cores, 36 threads, you know, overclockable, you know, with, of course, also now supporting Turbo Boost 3.0, which allows for really, really impressive single core peak frequency. Some really cool, interesting stuff. We actually did a whole stream on Turbo 3.0 technology. So you guys can actually check that out by searching the Newegg Now live streams if you guys want to find out more about Intel Turbo 3.0 technology. Some really, really cool stuff there. So there's 7 overall processors. I think one of the really cool things that also Intel did for these X series parts is that even going down to the entry level, there's no more kind of weird split between the PCIe lanes, where some of the entry level models had like lower PCI Express lanes.
Yeah.
Still more than Z series chipsets, but it wasn't as much as the higher end. But now they're maintaining it to be contiguous.
Well,
so
just like we saw
everything.
that improvement in the Z series moving us up a notch, it seems like the bottom end of the X299 also faced that same, or also encountered that same kind of improvement across the entire line of products.
Yep. So cool part there is, like I said, just being able to really, it's pretty crazy to me that you can build essentially an Intel platform that is giving the ability to go from 8 cores all the way up to 18 cores on the same exact platform. So really for somebody that maybe wants to start off, maybe they're a content creator, gamer, a streamer, they're kind of want really, really great performance, and they make an investment in the system, but maybe 2 years later they want to be able to jump up to significantly more performance.
Again, I mean, like you build
know?
the system, you don't know where that's going to go over the life of that system.
Right.
So,
And here, even now with Z390, you could argue you have a very similar level of flexibility that even the top end part, that 9900K, 8 cores, 16 threads, right? But you know, you go into X299 and you go into a whole nother ballpark. For ASUS, I can tell you that we will have some upcoming refreshes, including already a confirmed X299 Deluxe version 2. So we will have that board coming out to the market in the not too distant future, so stay tuned for that. It's a beautiful looking board, and maybe there might be something on the ROG side of the fence, I'm not sure.
perhaps.
But beyond that, though, Intel, I think, dropped something that nobody was expecting, and this is something that's even apart from X299. And this is going to be a Xeon-based platform with the Xeon W3175X. ASUS is very lucky to be a key partner collaborating with Intel in the design and development for this platform, and being offering one of the actual boards that will be suited for this platform in the ROG Dominus. So this is going to be for a 28 core. Absolute monster that supports overclocking. So historically, Xeons have never allowed for overclocking, but they will. So now what I'm going to show you are some images of this board, and just be prepared to be blown away, because it's absolutely amazing.
You got to check this out, because it sounds like the evil dinosaur from the new Jurassic Park films, because it kind of is.
So let's go ahead and cut over here.
Yeah, let's go ahead and throw it to the slide.
And show you guys right here. So this is
huge.
The ROG Dominus, 6-channel memory, U.2, a specialized extended form factor, an absolutely monster, specially designed custom VRM assembly, which is designed to be able to handle the absolute level of cores and threads for this system. If you are looking to build the absolute biggest, baddest monster of a system, you are going to want to take a look here at the Dominus. The Dominus is just an absolute insane system with tons of connectivity, entirely specialized, and of course, many of all the key technologies and features and designs that we've talked about today are going to be baked into this board. So not only are you going to get the amazingness that's going to be in that platform, but you're also going to get this. So I'm going to tease you guys with a couple of other little shots here, a little low-profile shot. You can see here. I think it just
That-
looks
so,
beautiful.
some
One thing that you might
beauty
not notice
photography here.
is that this shroud will actually be built from aluminum. It won't even be featuring plastic. So
Wow.
this is going to be a whole nother class in terms of kind of a premium design. Here you can see all those DIMM slots and dual DIMM.2. So you see right here, that's that DIMM.2 slot. This board doesn't have one DIMM.2.
It has two.
It has dual DIMM.2.
So how
plus additional M.2. I'm not going to tell you all the specs because we're not talking about all the specs, but I'm going to tell you right now that at a minimum that means at least four M.2.
Right, yeah.
Because you got dual DIMM.2
at a minimum
on this board.
But maybe
right.
There
There you can see the other DIMM.2 on the other side of the board, the advanced fan groupings that are on this board. And then I'll just leave you with that beautiful shot of
Oh, that's pretty.
just a lot of wonderful.
That's a lot of
memory
RAM.
on that board. So
Oh, that makes me happy.
this platform is going to be an absolutely insane platform. There are also some new technologies that are absolutely game-changing. Intel's introducing AVX 512 instruction sets. We're only starting to see now some of the higher-end AVX instruction sets in 256, but AVX, keep in mind, because of its improved encoding efficiency, can offer exponential increases in performance. So as we're getting applications that are now starting to leverage these current instruction sets, I can't even imagine that if we get an application that's 512 AVX instruction set with that level of threads, right, and then the level of memory channel performance, this is just like, it's just gobs and gobs of power, it's like, it's like Masters of the Universe or something
Totally.
like that.
Well, and that arms race and taking a Xenon-based part into an enthusiast sector.
Yeah.
I think this is something, like, especially from my perspective, is something I've always kind of wanted to see Intel make a move this aggressive with the technologies that they have in different channels.
Yeah. So hopefully, guys, you guys have found some stuff that's interesting. We've had a lot of different stuff that we've talked about. We've hopefully given you guys a little bit of a primer on understanding the new SKUs, right? It's 9th gen SKUs that have come out. 3 of them, 9900K. It's that first 5 gigahertz mainstream part, right, in turbo, but supports overclocking. You got the 9700K, the 9600K, the sleeper. Z390 based chipset. We've talked about our Prime series, Tough Gaming, Strix Gaming, WS, and then ROG.
WS.
A lot of different boards here, a lot of advanced features from everything from our AI overclocking technologies to our fan expert to our audio designs, networking, UEFI, and so much more that we haven't talked about. Hopefully you guys have a better foundation and understanding so that if you're now interested in building your next gen Z390 based system for whatever it might be, whether it's going to be for gaming, content creation, streaming, or a little bit of everything, you're going to now know which is the right board to go with, and you can pair it with one of these awesome 9th gen based CPUs. So unless we got any pending questions.
Actually, I think we're good to wrap this up. A lot of the questions that we got just recently have actually been sort of addressed in getting to the end. A lot of people are asking about what we were teasing.
Fantastic.
So definitely some interest there in some of the higher end parts, some of those higher end components. But JJ, are we gonna have you back soon so you can show us maybe what that 9600K?
Oh yeah, sure.
do?
Actually, yeah,
wanna see what that clock
you guys
speed
make sure to keep it tuned. We've actually got more content coming to you here on the Newegg YouTube channel. So in the not too distant future, we're going to have overclocking guides. We're going to have build guides for ATX and for Mini ITX. So we're going to be giving you guys all the ins and outs. If you want to get the best experience possible from Z390 and from 9th Gen series CPUs, make sure to subscribe. Keep it tuned. Content's going to be coming in the not too distant future.
Just want to get this guy back out here too. So as we're wrapping this stream up, if you're wanting more information, not just on Core i9, but what your Core i9 is gonna live in, definitely check out newegg.com/Intel 9th Gen. That's /Intel 9THGEN. We'll have links below on the stream on both the YouTubes and the Facebooks, especially if you guys are watching this on newegg.com. You're already pretty much there, so you should just go ahead and check it out. That's gonna do it for us today, guys. Some really exciting stuff coming down the pipe, and this competitive factor, this competitive enthusiast space is just heating up, getting way more exciting, and we'll definitely have some more information for you guys, future episodes of Newegg Now and on future live streams, so be on the lookout for that. Once again, newegg.com/Intel 9th Gen. Check it out. This is going to be some beastly performance.
For sure.
Good times there. Thank you so much for watching, and we'll definitely be hitting you guys up soon with some future live stream and some more content on what you can do to get the most out of your PC build.